Hey, it's Juan Tutors, and today we are working on the January 2025 Geometry Regents. It's actually the last Regents in the old standards. We are switching to next-gen standards, but it happens to be that the standards, the new standards and the old standards are so close to each other that they're literally transitioning from one test to another. They're not even changing the name of the course. They're literally nearly identical. That's the best right now that we could say, nearly identical. And from what we see from the Algebra 1 test, the old Algebra 1 test and the new Algebra 1 test are nearly identical. We do expect the Geometry Regents is also going to be nearly identical. So let's work on this Regents as if it were the new Regents. Let's do the best that we can. The grading scheme is going to be very similar. Everything's going to be similar. And it happens to be that the Geometry Regents, despite the fact that I know a lot of students struggle with it, it happens to be that this Regents allows for an immense number of really cool test-taking strategies. My favorite of all being the using scale and just working on diagrams, either confirming that they are drawn to scale or assuming that they're drawn to scale. Because on this test, that blows up grades in good ways, all right? So the first thing that we're gonna look at before we even go into a problem, it does say that a graphing calculator, a straight edge, a ruler, and compass must be available to you while taking the test. Make sure that the school does give you the straight edge and compass, and make sure that the graphing calculator is also given to you. If they don't give it to you, that's a fault on their part. One of the things that they say is, where is it? I'm looking for it, and I found it. The part right there that says that note that diagrams are not necessarily drawn to scale. I cross out the words "not necessarily," and I have my students do this, and I have my students write "almost definitely." And it's written 5 times on this test. So, and I have students rewrite, I have students cross that out 5 times. And you'll see what I'm talking about when we're talking about scale. So right here are the instructions, and right here it is, note that diagrams are crossed out right there, almost definitely. Now, this test also says things like, there's no partial credit on the part 1s, but you should definitely show work. This is a fair warning. Before we even do number 1, a lot of students leave their test almost completely blank. We're going to see that the part 1 questions and the part 2, 3, and 4 questions are actually nearly identical to each other. And what that means is that if you are actually the kind of students who strongly believes that you should focus on the part 1s to do the best that you can on this Regents, it actually means that you should show all work and focus on the part 2s, 3s, and 4s equally. And we're going to see that it actually, just focusing on the part 1s is actually not a very good strategy at all. I know a lot of teachers say focus on the part 1s, and I know why they give the advice, and it's not complete enough advice. You do have to show work in order to do the best possible on the part 1s. So we're going to see that, but right now we're going to get to number 1. On the set of axes below, triangle A, B prime, C prime is the image of triangle ABC. And I do look at the figure and I see these 2 triangles. One, they look like right triangles. I see the triangles there. And it says, what is the scale factor and center of dilation that maps triangle ABC onto triangle AB prime, C prime? Is it 1/2 and the origin, or 2 and the origin, or 1/2 and vertex A, or 2 and vertex A? And right away, I see that this is actually a 2x2 problem. A lot of students struggle on this kind of problem because they see that there's like 2 conditions that they got to keep track of. And in fact, if you keep track of each condition separately, you actually do a lot better on the problem. Now, this one is probably a little bit easier to analyze than many. But I will use it to address the 2x2 problem. So what I call a 2x2 problem. So what makes this a 2x2 problem? They are testing 2 different conditions on this diagram. Is it a dilation of 1/2 or is it a dilation of 2? So D 1/2, or is it dilation by a factor of 2? And the second thing, is it centered at the origin, or is it centered at point A? And so the one that says that it's a half centered at the origin is choice 1. The one that said centered, dilation of 2 centered at the origin is choice 2. And then a dilation of 1/2 centered at A is choice 3. And then a dilation of 2 centered at A is choice 4. And so what we do, we can actually analyze the figure, and if you could figure out which of these is satisfied by the diagram, one at a time, you can actually get to the point where you could maximize your score. So over here, I notice that the length of AB is equal to 2. And I notice that the length of AB prime is equal to 4. I just count up A to B, that's 2 spaces up from 1, 1 to 1, 3. And A to B prime is 4 spaces up from 1, 1 to 1, 5. Now, it's also important to know which triangle is the image of which. So it says here that triangle ABC is the image of triangle, that it says that triangle AB prime C prime is the image of triangle ABC. So ABC is the original triangle, and ABC is transformed into AB prime C prime. So that is the length AB transformed to AB prime. That means that it's multiplied by 2. As opposed to dividing by 2, a lot of students get it wrong because they think that AB prime is shrunk to AB, but it does say that AB prime C prime is the image of ABC. So AB is transformed into AB prime. So it is a dilation by a factor of 2. Anyone that has a factor of 2 in it is more likely to be correct, and the other ones that have a scale factor of 1/2 are definitely incorrect. And right now we have a what I call a passing problem. I'm going to address what a passing problem is later on in this video, but we have 2 possible choices. Now the question is the dilation centered at A or is it centered at the origin? And I noticed that if the dilation were centered at A, then A wouldn't move to form A prime, and in fact it doesn't. B, if the dilation is centered at A, B would double in distance from point A perfectly vertically from A, because B is perfectly vertical from vertically placed relative to A, which does happen. So this seems to be a dilation centered at A. If the dilation were centered at the origin, then A prime would be at the point 2, 2. B prime would be, instead of the point 1, 3, it would be at the point B is at 1, 3, so B prime would be at the point 2, 6, which is not the case. So this is definitely centered at A. So the ones that say centered at A have a piece that's correct, and the ones that say centered at the origin are not correct. The only one that has 2 check boxes is choice 4, so that is our answer. Okay? Every single problem that I do, I'm going to give you a hint for process of elimination even before I do the problem fully. Every single one. Why? Because you need strategies that can maximize your grade, and the strategies that maximize your grade include strategies that eliminate answers for questions that you don't know how to do. So I want to make sure that you get strategies for eliminating answers, but I also want to make sure that you know how to do every single problem. So in number 2, line segment PAQ has endpoints whose coordinates are P, -2, 6, and Q, 3, -4. What are the coordinates of point A such that PA to AQ has a proportion of 2 to 3? Is it 1, 0, 2, -2, -1, 4, or 0, 2? And what I'm going to do with this diagram, I'm going to just do a quick rough graph of this -2 and 6 up here, and that's point P, and then point Q is at 3, -4. That's around here. So if I draw this line segment, okay, perfect, I see that to have a proportion of 2 to 3, point A has to be closer to P than it is to Q. Point A has to be closer to P than it is to Q. And so what that implies is that, let's see, that whatever of these choices are closer to P -2, 6 than they are to Q 3, -4 could be the answer. Now the midpoint, this is going to be a strategy for process of elimination. The midpoint is equal to the average of the two. So -2 plus 3 over 2, comma, 6 minus 4 over 2, which is equal to 1/2, comma, 1. So the point has to be to the left of 1/2, comma, 1, which does eliminate choice 2. So we've eliminated at least one choice, which is great. I'll take eliminating one choice because now we have a 1 in 3 chance of getting it right. But I also note that to have a proportion of ratio 2:3, it has to be not so close to P that the ratio becomes bigger. And if I draw these points where they're located, 1, 0. Actually, 1, 0 gets eliminated. My mistake. So this is actually not my mistake. It's a blessing for us because we actually now have what we call a passing problem. And again, we're going to talk about what a passing problem is later on in the test. But this point -1, 4 is very close to P, whereas this point 0, 2 is close to the middle. And if you remember, the midpoint was right there, 1/2, comma, 1. So we are looking very good for this answer, and this answer is not looking too good for us. Let's talk about the notation that I just used to help me keep track of what I know and what I don't know, what I think is true, what I think is not true. I crossed out choice 1 and choice 2 at the number because I knew with 100% certainty that those were incorrect. I put an X next to choice 3, but not on the number 3 because fake student me strongly suspects that choice 3 is not correct. Of course, real teacher me knows that it's definitely not correct. And fake student me knows that, suspects strongly that now that choice 4 is more correct. So that if I really can't figure it out and I had to guess from this point, now I actually have a good reason to guess choice 4. I would get it right and I would get the points, which is great. So how do we actually do this problem algebraically? So let's call A the point X, comma, Y. And we know that A to X, P to X, and then X to Q has to be equal to ratio 2 to 3. So if I plug in the choice that I strongly suspect is the answer, that would allow me to test it manually. However, so would I do that in a part 1 question? Absolutely, because it's a multiple choice question. But I do have to do it algebraically because in a part 2 question, they could easily ask us this question and we have to actually do the algebra carefully. So how do we do it? We know that the ratio from P to Q, which is X minus -2, divided by the ratio from A to Q, which is the X coordinate 3 minus X, that has to be in a ratio of 2 to 3. And if we actually do some from algebra class, some cross multiplication, so clearly we don't get to escape algebra here, we get that 3 parentheses X minus a -2, so X plus 2, is equal to 2 parentheses 3 minus X. You use the distributive property twice, and we get that 3x plus 6 is equal to 6 minus 2x. Let's see, add 2x, add 2x. Might as well subtract 6 at the same time. And we get that 5x equals 0. Divide by 5, and we get that x is equal to 0 over 5, which is 0. So we now know that the x coordinate is 0, confirming that choice 4 is the answer. We could do the same procedure to get the y coordinate. We would do, I'm not going to do this one because our goal is to get this question right, but I do want to at least show you how you would do the problem on a part 2. So this would be from P to Y, from P to A, which means from 6 to Y. It's y minus 6 over from A to Q. q minus the y coordinate of q minus the y coordinate of a. So negative 4 minus y. That's equal to the same ratio, 2 over 3, and you would solve this equation the same way you solved the first equation. Either way, we confirm that the x-coordinate is 0, and if we just do a quick check to see if the y-coordinate of 2 satisfies this, 2 minus 6 is negative 4, which is negative 4, and negative 4 minus 2 is negative 6. And does negative 4 over negative 6 equal 2 over 3? Absolutely. Divide by negative 2 and we get 2 over 3 equals 2 over 3. So it does check, and the answer is choice 4. Let's shrink the size of this problem a little bit. Now, just so you know, I am not going to be doing any editing to this video. Any coughs, any sneezes, any pauses that I have to make at all, any like sips of a drink that I have to take, I'm gonna do that without making edits. Why am I doing that? Because every year I used to spend maybe 5 times as long that it takes to make the video on editing the video, and then one day I realized if I just don't edit the video, I could put out all the Regents like people have been requesting. There are many years where I don't get to all the Regents because I'm spending so much time editing. So take that sip, and we go on to number 3. On the set of axes below, congruent parallelograms A, B, C, D, and R, S, T, U are graphed, and they do look congruent. A, B, C, D, R, S, T, U. Okay. Which sequence of transformations maps A, B, C, D onto R, S, T, U? A reflection over the x-axis followed by a translation 10 units to the left and 1 unit up, or a translation 4 units down followed by a reflection over the y-axis, or a reflection over the y-axis followed by a translation 2 units down, or a translation 10 units to the left followed by a reflection over the x-axis. Now, there is something that's important to know. The ordering of the vertices matter. I didn't check previously whether there is a transformation that maps one parallelogram onto another but doesn't map the correct vertices onto another. So for example, it is possible to map A to R and B to S, C to T, and D to U, which is the goal, because notice in the ordering of the names A, B, C, D onto R, S, T, U. But it is also possible to map A to T, which is, and then let's, for example, C to R, which is the 180-degree rotation of that system. So we do have to make sure that the answer that we get does map the correct vertices to the correct vertices. So the only way, there are a lot of ways to do this. So you can maybe look for a transformation yourself and then see if it's the one that you found is there, like translating 4 units down and then reflecting. But let's see what this actually says. If I reflect over the x-axis, then I get this. I get D over here, D prime over here, and I get A prime over here, and I get C prime over here, and I get B prime over here. Okay? Which now, if I take this, now notice here, no translation is going to map A prime to R, while also mapping C prime to T. Let's see what this one says. 10 units to the left and 1 unit up. So we see in this diagram, if we do translate this parallelogram 10 units to the left and 1 unit up, it maps the parallelogram onto the other parallelogram, but it maps the wrong vertices to the wrong vertices. So it maps C prime to R, which means that this choice 1 maps C to R. We can't do that because the transformation has to map, by requirement, has to map A to R. So choice 1 is not the answer. Let's do some erasing so we have some more space to draw. How about a translation 4 units down followed by a reflection over the y-axis? I like that one because that's the transformation that I was noticing. This is A prime and this is D prime. translate B 4 units down to B prime, and translate C 4 units down to C prime. And we get this parallelogram. Let's see. Okay. Oh, didn't straighten that one. Okay, then if we take this parallelogram and we reflect it over the y axis, as choice 1 says, then A prime gets mapped to R, D prime gets mapped to U, perfect. C prime gets mapped to T, which is great, and B prime gets mapped to S, which is great. So now we know for sure that the answer is choice 2. So the way to do this problem is really going down the list and working on them one at a time. That's the trick to that one. Number 4, triangle ABC has a right angle at C. If AC is 7.7 and the measure of angle B is 24 degrees, what is AB to the nearest tenth? Is it 18.9, 17.3, 8.4, or 3.1? And this one, I'm going to use scale, even though I'm going to draw the figure myself. I'm going to use scale because I need to draw a right triangle with right triangle at C, and angle B is 24 degrees, which means it's a fairly, okay, didn't mean to do that, but okay. It's a fairly long triangle. So that, I'm going to make that angle B 24 degrees. And then AC, C is the right angle, and then A is over here. So AC is 7.7. And what is AB? What is the length of the hypotenuse to the nearest tenth? Now I know that, well, first off, AB is greater than 7.7 because the hypotenuse is longer than every other side of the triangle. That eliminates choice 4. But I actually happen to remember, if you happen to remember this detail on the 30, 60, 90 triangle, let me draw this 30, 60, 90 triangle, 30, 60, right angle. You have x and x radical 3 and 2x. That the hypotenuse is twice as long as the smaller side of that triangle, and this triangle has a angle of 24 degrees, which is smaller than 30 degrees, which makes the side opposite the 24 degree angle smaller than half the hypotenuse, which means that the hypotenuse is going to be bigger than double that AC. So in fact, AB is actually going to be greater than 2 times 7.7. So which is equal to 15.4, which eliminates choice 3 as well. And now we're kind of left in a lurch if our only way of doing this problem is guessing. So clearly we have to go into some of the algebra. However, this did eliminate 2 choices, and this is the point that we're going to talk about: a passing problem. Passing problem. You'll see me label some problems PP or for a passing problem. Every Regents that you can eliminate, if you can eliminate 2 choices, you've created a passing problem. But the reasons are different for each Regents. On the math Regents, here are the actual reasons. If you look at the conversion chart for the geometry Regents, to get a 65, remember, to get a perfect grade, you need 80 points, but to get a 65, you actually only need, in this Regents, 31 points. 31 points. Well, if each multiple choice question is worth 2 points, how many multiple choice questions do you need to pass the Regents? Well, that's 15 and a half. 15 and a half, which is actually, out of 24 questions, it's more than half the multiple choice questions. 15 and a half. Of course you can't get 15 and a half, but you could say, oh, but then that means it's 16. Or you could say what's better, you can eke out a few points in the part 2s, 3s, and 4s, and you could actually reduce the number of multiple choice questions that you need down to maybe as low as 12. Excuse me, 12 or less. And that's actually the point. That right there is actually the point. If you get points in the part 2s, 3s, and 4s, that reduces the number of multiple choice questions that you need to pass down to 12 or fewer. 12 is half the multiple choice questions. So if you get a multiple choice question down to 2 choices, half the choices in a multiple choice, then proportionally speaking, that question is neither lowering your grade relative to a passing grade, nor is it relative to a 65, nor is it raising your grade statistically relative to a 65. That's why it's a passing problem. If you get problems down to 2 choices, they do not lower your grade relative to a passing grade on average. Okay? Well, is there anything that we can do in some problems to get to the point where we can actually do better? In the previous problem, this one we just went through the choices one at a time, but this problem we were down to 2 choices. So this one became a passing problem, but not only was it a passing problem, but we actually had really good reasons to believe that choice 3 was absolutely incorrect and that choice 4 was 100% correct. So even though we got it down to 100% certain passing problem, we actually got it to 99% chance that we got it right. And in fact, if you recall, with this one, problem 1, we actually were able to eliminate choice 1 and choice 3, turning the problem into a passing problem as well. And for really good reasons, we had reason to believe that the dilation happened centered at A, so we actually were very likely to get that problem correct. Now this problem, between 17.3 and 18.9, I personally don't have a reason to doubt whether one answer is the correct answer or the other, and so unlike the previous 2 passing problems where we would have been very likely to get the question right, now we might have a 50-50 chance of getting it right, and maybe you're better at intuitively guessing on this kind of problem than I am, but I have no good reason to suspect 18.9 versus 17.3. So we have to go into the problem the way we would in a part 2. Notice we can't get this question right without actually using the skills that we would use in a part 2 problem. So this is truly a part 2 question, even though it technically has multiple choice. And how do we do this? Well, we recognize that the side AC is the leg opposite to angle B, and then the AB is also the hypotenuse. And so I remember my rule of my SOHCAHTOA. I no longer write SOHCAHTOA in a line. I learned this from a student. Shout outs to Abby, who showed me how to do this. S-O over H, so, ka, C-A over H, TOA, T-O over A. And I see that the one that has the opposite leg and the hypotenuse is the sine. So we have sine of angle B is equal to the opposite leg over the hypotenuse, which is equal to AC over AB. And so then that means that sine of 24, delete that for a second, sine of 24 is equal to AC 7.7 divided by mystery AB. Now, how do we solve for AB? We put the sine of 24 over 1. We do the trusty cross multiplication. I used to hate cross multiplication as an operation, and now I think it's peachy because it fixes a lot of intuition issues. And we get that 7.7 times 1 is equal to AB times sine of 24. And now if we divide by sine of 24 on both sides of the equal sign, and then we go to our trusty calculator. So we have, let's make sure that we're in the correct mode, and we go down to degree mode, press enter, and then quit. So now we have to do sine of 7.7 rather. 7.7 times 1 is 7.7 divided by sine of 24. And that's equal to 18.93 and change. Where'd it go? There we go. 18.93 and change, which is choice 1. That's where these went. So with number 5, we're about to get our first 10 points. Number 5, given that triangle PQR and triangle LMN with PQ congruent to LM, which additional statement is sufficient to always prove triangle PQR is congruent to triangle LMN? So let me just make a quick list of the theorems that I have to prove triangles congruent. I have side, 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 angle, side. That's the only one with an angle. And then with two angles, angle, side, angle. And then angle, angle, side. Now, we also have hypotenuse, leg. And there's one that's not often used, but hypotenuse angle is a valid theorem to prove triangles congruent. The reason it's not normally talked about is that hypotenuse angle does boil down to angle, angle, side. Whereas hypotenuse leg is very unique because it actually boils down to side, side, angle. And in fact, we have to know not side, side, angle. I know that it spells a swear word backwards or forward, one of those two. And so we don't not teach it to you just because it happens to spell a swear word in one direction. We actually don't teach it to you because it's false. Side, side, angle or angle, side, side, you can actually find two triangles that satisfy the angle, side, side proportionality or congruent statement, and they're still not congruent. And when it comes to similar triangles, you could find two triangles that satisfy the angle, side, side proportionality relation, and they're still not similar. So these are, on the left, these are the 6 or 5 or 6 congruent statements. So what are we going to do? We are going to make one scalene triangle, and then let's see if it'll let us copy this triangle. Control-C, Control-V. Sure. Perfect. And it does tell us that P, Q, R, and LMN, our goal is to show that they're congruent, and then P, Q, R, and then L, M, N, and they tell us that PQ is congruent to LM. So which other statement is sufficient to prove that the two triangles are congruent? I'm seeing that all of them have one pair of sides and one pair of angles, so one of them has to boil down to side, angle, side, and 3 of them have to boil down to side, side, angle. And so what's the difference between side, angle, side and side, side, angle? Side, angle, side means 2 pairs of sides, 2 pairs of sides are congruent, and A angle is in between the 2 sides, so the included pair of angles are congruent. So when I said that this has to boil down to side, side, angle, that's actually one of the things it could boil down to. Another one is that it could boil down to side, angle, side on one of them, but side, side, angle on the other one. So let's see. Choice 1 says that QR, actually they all say that QR is congruent to MN. That's interesting. That makes things easy. So QR is congruent to MN, that's 2 dashes. Okay, and so then the last condition that we need to confirm is that the included angle is the set of angles that's congruent. So angle Q is congruent to angle M. That looks very good right now. And then the other choices are not looking good at all. Angle R congruent to angle N. That would be the non-included pair of angles. This would be side-side angle, which makes this wrong. Angle P congruent to angle L. 2 dashes here, 2 dashes here. That again is the non-included angle. It's not between sides PQ and QR. So this is another side-side angle. And now angle P is congruent to angle M. So this is one where it's like side-side angle on the left on triangle PQR and side angle side on the right side triangle, which definitely can't be a theorem. So this would imply side-side angle congruent to side angle side. That's not a thing at all. So that eliminates choice 3 and choice 4, definitely confirming that choice 2 is the correct answer. Let's hop right over to number 6. The equation of a circle is x squared plus 6y equals 4x minus y squared plus 12. What are the coordinates of the center and the length of the radius? Center 2, negative 3, radius 5. Or center negative 2, 3, radius 5, or center 2, negative 3, radius 5, 25 rather, or center negative 2, 3, and radius 25. This is another 2 by 2 problem. The question is the center 2, negative 3, or is the center negative 2, 3? And also, is the radius 5, or is the radius 25? And so if you look at it as a 2 by 2 problem, if you try to verify both conditions simultaneously, you'll get messed up. But if you actually try to verify each condition separately, you'll be more likely to get it right. I see that these numbers are not so large. I know that the equation of a circle is x minus h squared plus y minus k squared is equal to r squared, where the radius, not surprisingly, is equal to r, but the center is equal to the point positive or h comma k. And yes, h is being subtracted from x, and k is being subtracted from y, and that's the equation of a circle. Now, this is making me strongly suspect that choice 3 and 4 are not correct. Why? It's not because of the center, because they have two different centers. It's the radius. To have a radius of 25, r squared is 625. There is no way that in the process of completing the square to get the equation of a circle that I'm going to get a 625. No numbers are going to be brought into the problem that are that big. So that actually, basically for me, confirms that choice 3 and 4 are not correct. Okay? So now we have a passing problem. A passing problem. If you're not willing to eliminate choice 3 and 4 for sure, because maybe there's a plausible reason why 625 would appear in the problem, fine. But I know for a fact I cannot get a 625 anywhere in the problem, which eliminates choice 3 and choice 4 for me. So now the question is it choice 2 or choice 1? I am liking this one over this one. For having to do with the fact that the x coordinate of the center is going to be subtracted from x, and the y coordinate of the center is going to be subtracted from y. So how do I actually do the problem as if it were a part 2 question? Because notice, we can't really do much with this question unless we actually do the algebra, which means that this question as a number 6 as a multiple choice and this question as a part 2, really identical. And that's again what I said. We really can't be focusing on the part 1s without actually focusing on the part 2s. So how do I do this? I actually complete the square twice. So we got x squared plus 6y equals 4x minus y squared plus 12. I'm going to subtract the 4x, but I'm also going to add the y squared, and I'm going to leave the 12 on the right side. And I get I get x squared minus 4x, leave a blank, plus y squared plus 6y, leave a blank, equals 12. And so now what do I do with these numbers? I'm going to complete the square twice. I'm going to complete the square twice. So x, I'm going to do x and then y procedure. Okay? What I write is I write b. I write b over 2. And then I write parentheses b over 2 squared. So b for x is the x coordinate or the coefficient of x. That's b. So that's -4. b over 2 is -4 over 2 is -2. And then b over 2 squared is -2 squared, which is a +4. So I'm going to add b over 2 squared. So add 4, but if I add 4 on the left side of the equal sign, I got to add 4 to the right side of the equal sign. And now I'm going to follow the same exact procedure on the right side of the equal sign. So I write b equals, well, that's b right there, 6. b over 2 is equal to 6 over 2, which is 3. And now b over 2 squared is equal to 3 squared, which is 9. So I'm going to add the 9, And why am I doing that? So notice I'm going to use the highlighter here. I added 4 here, and I added the 9 here. And now I'm actually going to use the b over 2 to finish completing the square. Okay? So the first half, the x squared minus 4x plus 4, actually factors as x minus 2 squared. And then the y squared plus 6y plus 9 is going to factor as y plus 3 squared. And then the right side is equal to 12 plus 4 plus 9, which is 25. Okay? So where did these numbers come from? Well, this over here, this minus 2 is this minus 2, and this plus 3 is this plus 3. So at this point, I remember that again the equation is x minus h squared plus y minus k squared is equal to r squared. So that confirms r squared is equal to 25. Take the square root, take the square root. You do get a plus or minus, but we reject r is equal to -5 because radii are positive. So that r is equal to 5. Okay? That does confirm that choice 1 and choice 2 might be the correct answer. And here I'm subtracting 2, so h is equal to 2. And here I'm subtracting k, but I'm adding 3. That's the same thing as minus a -3. And so k is equal to -3. And so the center is equal to 2 comma -3. So the center is equal to 2 comma -3. It's just actually the thing that I suspected was true. Again, I suspected it was true because of the coefficients and the sign of the coefficients. I didn't address that too much because I knew that I would have to go into the algebra already. Number 7, a square with a side length of 3 is continuously rotated about one of its sides. The resulting three-dimensional object, is it a cube with a volume of 9, or a cube with a volume of 27, or a cylinder with a volume of 27 pi, or a cylinder with a volume of 54 pi. So I invite you to think about what this problem does. So this is, you're taking a square, and you're rotating this about one of its sides. This is coming out of the page now. This is coming out of the page. So it's coming into a three-dimensional problem. Now, how do I imagine it? This is the thing that helps me. I imagine putting it on a drill bit. Putting it on a drill and spinning this and making a hole in the shape of what comes out. Well, the hole in the shape of what comes out ends up being circular. So we end up, so if I'm spinning it, this is a length 3, this is a length 3, this is a length 3, this is a length 3. If I'm spinning it around, let's say this side over here, this side over here, then I end up getting, out of the page, I end up getting a circle from the top line, and I get a circle from the bottom line. And then this vertical line ends up over here. This is a cylinder. So it's definitely not a cube. Whenever you rotate something in 3 dimensions, you're not going to get straight flat sides. You're going to get curves. You're going to get circles. So it is a cylinder. Now, what is its volume? Well, it's got a radius of 3, because that's the center. So this is a radius. And this is also, this 3 is also the height. So now I try to remember the formula for the volume of a cylinder. And it does happen to be that that equation is at the back of the test. Cylinder, the volume is equal to pi r squared h, so that's equal to, the volume is equal to pi, r is 3 squared times height 3, so that's equal to pi times 9 times 3, which is equal to 27 pi. And that gives us this answer. Number 8, line K is represented by the equation 4y plus 3 equals 7x. Which equation represents a line that is perpendicular to line K and passes through the point negative 5, 2? Is it y plus 2 equals 4/7 x minus 5? Or is it y minus 2 equals 4/7 x plus 5? Or is it y plus 2 equals negative 4/7 x minus 5? Or is it y minus 2 is equal to negative 4/7 x plus 5. This is another 2 by 2 problem. And this one's not as obviously a 2 by 2 problem, so I'm going to actually make the 2 by 2 box for this one. Okay? Yep, it's not going to straighten that one. Okay, so I noticed that the question is the slope either 4/7 or is the slope negative 4/7? And also, does the equation have a plus 2 and a minus 5? Or does the equation have a minus 2 and a plus 5? Put an and symbol instead of a comma. Those are really good questions. So, but if you answer one of these questions at a time, you can get the answer. So, slope of, so that's choice 1. Slope of 4/7 and with the numbers negative 2 and 5, that's choice 2. Slope of negative 4/7 with a plus 2 and a minus 5, that's choice 3. And this one's choice 4. So let's see which one I'm going to address first. I'm going to write this equation in slope-intercept form. So I got 4y plus 3 equals 7x. I'm going to subtract 3. I got that 4y is equal to 7x minus 3. If I divide by 4, I get that y is equal to 7 over 4 x minus 3 over 4. And what does that imply? I'm going to put this up here. The slope is equal to 7 over 4. That implies that the slope of any parallel line is going to be equal to 7 over 4. And the slope of any perpendicular line, which is what we really care about, is going to be equal to the opposite reciprocal of that number. So negative 4 over 7. That confirms that anyone with the slope of 4 over 7 is 100% incorrect. And now we have a passing problem. PP, passing problem. So now the question is, we need the point to, the line to pass through the point negative 5, 2. And I'm starting to suspect that this is the correct answer and that this one's wrong, because I remember the equation, the point slope form of an equation, point slope form. I got y minus k is equal to m parentheses x minus h. And so this line passes through the point -5, 2. So that's k, that's h. And we got y minus 2 is equal to the m, -4/7, parentheses x minus -5, or x plus 5, which does match choice 4, as I suspected. We went right past 9. And we're halfway to passing. With number 9, we are actually halfway to passing. Number 9, scaling triangle JKL is drawn below, and it does look like a scaling triangle. If median LM is drawn to side KJ, which statement is always true? Is it that LM equals KM, or is it that KM is half of KJ, or is it that LM is perpendicular to KJ, or is it that angle KLM is congruent to angle JLM? So I'm going to draw as best as I can the midpoint of KJ, because the median is the line segment connecting the vertex to the midpoint of the opposite side. Let me try drawing that again. There we go. Okay, so now based on this drawing, which ones seem to be true? Does LM and KM, I mean, I'll admit, LM and KM do look similar. But if the triangle was just squished a little bit, we could test whether that one makes sense by drawing a less extreme triangle. LKJ, and put M over here. And if I draw this line segment here, does LM look the same size as KM in this triangle, even though that's a median? No. So it can't be that one. Now, does KM, is the measure of KM half of KJ? This does look right, because this is, M is the median of M is the midpoint of KJ. So KM being half of KJ does make sense. So this is looking like the right answer. LM, perpendicular to KJ, we could actually just see that these are not perpendicular. This is a very acute angle. This is a very obtuse angle. Very false. And now this one, angle LKM, LKM congruent to angle JLM. I mean, 2, 3. Those are just very different angles. We got like a 60-degree looking angle compared to like a 15-ish degree looking angle. No, that's very false. So even, I mean, we were able to throw away 3 incorrect choices. This one is very correct, because again, M is equal to the midpoint of KJ. So it cuts KJ in half. So each half is half the length of the full line segment. Number 10, in circle O, chord KA intersects diameter YN at S. So let's look real quick. KA intersects diameter YN at S. And they told us it's a diameter. They told us it's a diameter, so that's a big deal too. If the measure of arc YK is 120, the measure of arc YA is 105 degrees, what is the measure of angle ASN? So I know that the measure of angle, the measure of arc NA plus the measure of arc AY, because YN is a diameter, arc NAY is 180 degrees, so that's 180 degrees. So that I got the measure of arc NA plus the measure of arc AY, which is again 105, is equal to 180. Subtract the 105, subtract the 105, and I get that the measure of NA is equal to 75 degrees. Now, before I do the calculation for the measure of arc of angle ASN, I always tell students to use scale when doing these problems. We used scale when doing this problem by verifying that a statement was false in this one, didn't we? If a statement looks to be false, it has to be false. If the diagram is drawn to scale. This diagram is drawn to scale, meaning the locations of everything is exactly where it is, where it has to be, because they never said, in this case, that this one's not drawn to scale. And when it comes to graphs, graphs must be drawn accurately for the problem to be doable. So since their graph is necessarily accurate, and they're actually asking us to do problems based on the accuracy of the problem, we can assume that that diagram is drawn to scale. Now this one, suppose that you didn't assume the diagram is drawn to scale, but you had to guess. So you could ask yourself, what kind of an angle does angle ASN look like? It looks to me like a slightly obtuse angle. It doesn't look to me like a 120-degree angle, because I kind of have seen those a lot of times, but if you haven't, it doesn't look like a 120-degree angle. 120-degree angle is the opposite, is the supplement of a 60-degree angle, and KSN doesn't look like 60 degrees. So if I'm just using scale, this one's looking good to me, this one's not looking good to me, this one's looking terrible to me, and this one's also looking terrible to me because these are both acute. So you can use scale to answer questions. Suppose I didn't know how to do the problem, but I guessed at 97.5. I just move forward with points. So that's what I love about this Regents. You can get so many points out of the test by just using scale. So how do we do this problem? There is another way to identify that the angle ASN is bigger than 75. If you actually draw a parallel line to SA here, then NO, I'm going to call it P, NOP has to be congruent to ASN, and this arc is greater than 75 degrees, so the angle has to be greater than 75 degrees. And that does confirm it for sure, if you didn't like my arguments about scale. But now, how do we do this problem? There is a theorem that says that that angle inside of the circle, its measure is going to be the average of the two arc measures. So the measure of angle ASN is equal to the average of arc NA and arc KY. So if I put those numbers into this equation, I get that this average is equal to the average of 75 and 120. We divide that by 2, and I get, so the 195 divided by 2. And I would do that on the calculator. I would not be ashamed of having to do basic arithmetic on the calculator. I wouldn't even call this basic arithmetic. I would plug this into the calculator, and I would get 97.5 degrees, which is what I suspected based on scale. Excuse me. I'm also getting over COVID. I had it like 2.5 weeks ago. So I'm good. I'm feeling fine, but when I'm talking a lot, I get coughing. Number 11. Triangle ABC is graphed on the set of axes below. The vertices of triangle ABC have coordinates A, -3, 4, B, -5, -1, and C, 3, -2. What is the area of triangle ABC? So you could do this problem in a lot of different ways. I saw, if anyone's interested in seeing a video on the shoestring method, or the shoelace method, I'll totally do one. I'm not going to do it that way here because it's a very particular way of doing the problem. But it does give you the area of all polygons, not just triangles, which is phenomenal. There's also ways of doing this problem by counting dots. And in fact, counting dots does give us a very good estimate. In fact, because counting dots and counting squares is a very similar thing. If you count, there is a rule that if you count the dots in the inside, then count the dots on the edge as halves and count the corners, I think, as quarters. Then I think that'll be the area, or rather, no, you don't count the corners as quarters. That doesn't work. I think you count, well, something along those lines. If you remember what the rule is, post it in the comments. I think you count the corners and maybe subtract something like that. I can't recall it right now. If you remember it, definitely post it. But how am I going to do this problem? There's so many ways of doing this problem, and this is usually a part 2 problem, which I like. I like the fact that they're putting it on part 1. If you break up this triangle into pieces whose areas you can get more easily, that's the way to do it. There is a standard way of breaking it up. Just go straight down to here, go straight to here, and then from here go straight to this corner. But I'm not going to do it that way today because I see that there's a nicer way. If I just go horizontal, it doesn't always work out that you get a corner on an edge. But if I do that, then I'm going to call this point D. Then the area of triangle ABC is equal to the area of triangle ABD plus the area of triangle BDC. So why do I do it that way? Because, well, triangle ABD and triangle BDC, I can get their bases and heights by counting. The height of triangle ABD is 1, 2, 3, 4, 5. And then the length of BD is 1, 2, 3, 4, 5, 6, 7. 7. So the area of triangle ABD is 1/2 base times height, so 1/2 times 5 times 7 times 5. Plus the area of triangle BDC is 1/2 its base, same literal line segment BD, times 7 times its height of 1. And so this is equal to 35 over 2 plus 7 over 2. And instead of getting decimals, I'm going to actually combine the two fractions, 42 over 2, which is equal to 21. I didn't go over any ways to eliminate choices, but actually a good way to eliminate choices, I should have mentioned this. If you actually count boxes, full boxes in the triangle, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then if you count partial boxes that have like half triangles, we got another 13, another 14, then another, you get a bunch over here. They add up to bigger than 16. And so if you pair up little bits with each other, you actually end up getting, like for example, this one down here with this one up here, that's a 15th. This one up here with that one up here, that's a 16th. Then this one up over here, take this sliver, move it over here, that's a 17th. And then you just have to get what the area of the bottom side is. So, and yes, okay. So 1, 2, 3, 4, 5. It's actually 16 and a half, my bad. But and then you get the area of the bottom. Or 17 and a half. Okay, sorry about that. Okay, either way. The area is 21. So there are ways to eliminate choices, but we'll leave it at that. Number 12. In triangle ABC below, DE is a mid-segment, and BD is congruent to DE. Which statement is always true? Is it triangle ABC is isosceles, or triangle ABC is scalene, or BD is congruent to BE, or DA is congruent to EC? So this triangle has a lot of structure. By saying DE is a mid-segment, we got that that's congruent to, I'm sorry, this congruent to this congruent to this, okay? And then they said that BD is congruent to DE, so that gets one line segment too. Now, which statement's always true? Is triangle ABC isosceles, or is triangle ABC scalene? So let's see. By putting these these segments here, we actually confirm that triangle BDE is isosceles, because BD is congruent to DE, which implies, because DE is the mid-segment, and therefore parallel to this side, that triangle ABAC is isosceles. So that actually immediately tells us this, and it can't be scalene because AC is congruent to AB. Now, if we weren't sure about that, could we analyze it any other way? Well, BD congruent to BE. Again, using scale. There's nothing that implies that BD has to be congruent to BE. And in fact, BE, this diagram seems to satisfy all the conditions that were given in the problem, so it is drawn to scale. Since BE looks bigger than BD, this one has to be false. Because we confirmed it is drawn to scale, it's drawn to scale. Drawn to scale. We confirmed that it's drawn to scale. And then DA congruent to EC. EC, again, it's the same deal. For the same reasons, these are not congruent. And I said I wouldn't do any edits to this video, but I had to go downstairs and get a cough drop. Ricola, if you want to sponsor this video, please do. So I'm going to be sucking on a sucking candy again. The noise will probably come out here a little bit, but I got to do what I got to do, you know. As we said, though, the answer to this question is choice 1. Number 13, as shown in the diagram below, JKL is parallel to MNOP. Sure looks it. Right? And that means we're going to get a lot of alternate interior angles congruent, same side interior angles congruent, and we want to be able to jive with those things and get this question right. And it also says that KRN is, and so you're just given that, and then OR is congruent to ON. Okay, that's an interesting set of lines to be congruent. And then if the measure of angle POR is 116 degrees, 116 degrees, and it sure looks to be that, what is the measure of angle LKN? LKN. So we're looking for that angle. So this is one where let's talk about scale. All the lengths, all the sides that look to be parallel are parallel. And then the sides that look congruent, OR and ON, they told us they're congruent, and they look congruent. And then the 116 degree angle does look like a 116 degree angle. Those are the only things that could be changed to scale. So this is drawn to scale. It says, what is the measure of angle LKN? Well, that's an obtuse angle that's very close to 116, if not exactly 116. 58 degrees is false because this thing is drawn to scale. But maybe it's 116, maybe it's 122, maybe it's 128. I'm not willing to make a conjecture on that yet, but yeah, not quite yet. Not quite yet. I do have a suspicion But like for example, like RN looks just ever so slightly bigger than OR to me, in my eyes, and which means that angle RNO is probably smaller than angle RON, which makes angle K LKR probably bigger than 116, but only tiny bit bigger. So I'm actually not liking this one. I'm liking that one, and I'm kind of not liking that one because that's a 12-degree difference. Is not that big, but those look so similar. So if I'm going to assume that it's drawn very well to scale, I'm liking number 3 as a choice. And how do we do this? So the only way to do this is by chasing numbers. So let's actually do that. So let's chase numbers. Like for example, this angle, if that's 116, the measure of that green angle that I just drew is 180 minus 116, which is equal to, according to my calculator, 64. 64. Okay? This line segment and this line segment are congruent, which means that triangle ORN is isosceles. With base angles, angle ORN, congruent to the other base angle, angle ONR. So if I call that X, so we call that X for a second, call that X also. I got X plus 64 is equal to the sum of the measures of the angles in triangle ORN, which is equal to 180. So subtract 64, I got that 2x is equal to 180 minus 64, which again is 116. We could have also done that by the high school exterior angle theorem. But if we divide by 2, we get that x is equal to 100 divided by 2 is 50, and 60 divided by 2 is 8. Now, angle, so that's 58 degrees. So put that with 2 dashes. And now angle ONR and angle LKR are same side interior angles, so they're supplementary, so their sum is 180. So we got 58 plus the measure of angle LKR, which is the goal for the problem, is equal to 180. Subtract the 58, and we get that the measure of angle LKR is exactly what I had suspected because of my keen eye, is 122 degrees. Number 14, the ratio of similarity of square ABCD to square WXYZ is 2 to 5. If AB is x plus 3 and WX is 3x plus 5, then the perimeter of ABCD is it 8, 20, 32, or 80? Well, the perimeter of ABCD is... I mean, I have the question, is it possible to do this problem with just intuition? I don't think so, but there are some answers that I strongly suspect are not right. I strongly suspect that 80 is not right, because if the scale factor is 2 to 5, that a perimeter for ABCD of 80 would imply that AB has a side length of 20, and then WX would have a side length of 50. And I don't see those numbers coming out of this X. So that's a little bit too big, and I also suspect that 8 is a little bit too small. But again, this is only suspicion. But that's worth noting. So how do we do this problem? Again, AB to WX has to be equal to 2 to 5. So that means that x plus 3 over 3x plus 5 is equal to 2 over 5. If we cross multiply, that operation that I used to hate and now love, I got 5 parentheses x plus 3 is equal to 2 parentheses 3x plus 5. Let's now do some algebra. We distributive property, we get 5x plus 15 equals distributive property again, 6x plus 10. Subtract that 5x, subtract the 5x. Might as well subtract the 10 at the same time. Subtract the 10. We don't have to do it at the same time, but we can. We get 5 is equal to x. And now that we know x, we know that AB is equal to x plus 3, which is equal to 5 plus 3, which is equal to 8. So that's where that 8 came from as a choice for students who don't look to see what they're actually asking for. They're looking for the perimeter of triangle of square ABCD. So the perimeter is equal to 8 plus 8 plus 8 plus 8, which is equal to 32. Number 15. In parallelogram ABCD below, diagonals AC and BD intersect at E. They sure do. This looks like a parallelogram. This is looking good. Which transformation would map triangle ABC onto triangle CDA? A rotation would definitely do it. Let's see if a rotation is a choice. Clockwise rotation of 180 degrees about point E is looking great. A 90-degree rotation about point E, well, that would take point B to somewhere perpendicular here, not to point D, right? This is choice C, choice 3. So that can't be it. And then a reflection over AC or a reflection over DB. So a reflection over DB. This one can be verified to be fully false because if you reflect triangle ABC over DB, it self-overlaps in multiple places near the center. Whereas we need to triangle ABC to only overlap its image at side AC because that's part of triangle ADC. So that's verifiably false, and now we've eliminated 2 choices. We have a passing problem. But now, why not a reflection over AC? A reflection over AC, a reflection over any line segment reflects a point to the point that makes a line segment perpendicular to the line of reflection. That's not even quite right. Perpendicular to the line of reflection. Let's try one more time. Perpendicular to the line of reflection and equidistant from the line of reflection. So this would be B prime in choice 4. Choice 1. So it wouldn't end up being at D. Okay? So choice 1 doesn't make sense. That leaves choice 4. And in fact, if you rotate about a point, all points make a line segment which are bisected by point E. So BE and BD are congruent, and that's actually known to be true. And CE and EA are congruent, so C is rotated to A, and A is also rotated to C. So choice 4 is the only one that makes sense. And with problem 16, remember, a passing problem is one where we eliminate 2 choices, and we really, on average, we only need 12 problems to pass the Regents, but that's only if we get some points on the part 2s. Or we eke out some points by doing process of elimination cleverly with a lot of other problems in part 1. But notice, all of this required focusing on the part 1s as if they were part 2 questions. Now, in this example, number 16, square pyramid. The square pyramid drawn below has a volume of 175. If the height of the pyramid is 21, what is the perimeter of the base? Let's put a 21 there. Put a 21 there. Okay? And then what is the perimeter of the base? So this is another one where they're asking for the perimeter instead of just the side length. Well, if, supposing I don't know how to do this problem, but I do something about scale. If I say, I look for the length of the edges, and I think about adding them up, I suspect strongly that 5 and 10 are not going to be the answer. Because 5 and 10 look way too small relative to the size of those line segments. Now, between 20 and 25, I'm kind of agnostic as to which of these answers makes more sense, because even though I could compare the line segments, this is a three-dimensional figure, so there could be some skewing due to the angle at which we're looking at the segment. So the 21 specifically could look shorter than it actually is relative to the edges, which is actually making me think that maybe 20 makes more sense than 25, even though the line segments look like they add up to more than 21. Because of the skewing of that altitude, it's probably longer than it seems. But how do we do this problem? Does the Regents have a formula in the back of the book? In fact, it does. Where is it? General pyramids. Oops. Pyramids. Okay, paste that there. Make that bigger. So the volume of a pyramid is 1/3 base times height. So the area of the base can be found by that equation. If the volume is 175, we've got 175 is equal to 1/3 the area of the base, B, times the height, which is 21. Well, let's do this division by 3. We could just do that quickly. 175 is equal to 7b. Divide by 7, divide by 7, and we get that b is equal to 25. And that's where the choice 25 came from, because students get the area b, and they think, oh, 25, they're done. But in fact, they asked for the perimeter. So the base has an area of 25. So we have a square with a base x, a side length x, and a side length x. And we got that x squared is equal to 25. Take the square root, plus or minus. We reject the minus because x is a positive, is a length. Positive length. Okay? So we get that x is equal to 5, and then the perimeter is equal to x plus x plus x plus x, which is equal to 5 plus 5 plus 5 plus 5, which is equal to 20. 20. Very nice. And we passed the test, so congratulations. But let's move on to number 17. Because our goal is not to pass the test, our goal is to get 100. And in fact, if you work under the assumption that your goal is to pass the test, you always are reaching for that small number. And I'll show you yet another reason why we want to focus on more than just the multiple choice questions. If we look at the conversion chart again, suppose that we get every single multiple choice question correct. Now, well, 24 times 2 is 48 points. We get 48 points. We got a 76 on the Regents. And you might be saying, I would be totally happy with a 76 on the Regents. But here's another interpretation of that problem. If you are aiming for only the multiple choice questions, you are not working for a grade between 0 and 100. You're working for a grade between 0 and 76. How far is a 76 from a 65? if you're focusing on the part ones only, you're trying to pass when your cap is 76. It doesn't quite work out so well. So our goal has to be to focus on the part 2s, 3s, and 4s. Number 17, a glass fish tank is designed to be placed on a stand in the corner of a room with perpendicular walls. The tank can be modeled using part of a cylinder as shown below. The inner length of the fish tank along the wall is 22 inches. Okay, and we see that. Okay, 22 inches, 22 inches. And the height of the tank is 27 inches. And there's a weird typo happening here on the actual test. I noticed this at work and at home. But how much water to the nearest gallon does the fish tank hold? And it does say that 1 gallon is 231 inches cubed. And so if I just make a quick estimate, if I change the 22 to a 20 times 20 and multiply by a height of 27, that's like, let's say it's 30, just to round it up a little bit. And so this is assuming that it's a rectangular box. This is 12,000. Then I would divide this by 231. If I just divide this by 200, I get 60. So I think the answer, I strongly suspect that the answer is going to be something about approaching 60. Now, what did I do? I assumed that the shape is a rectangular shape, and instead of a quarter of a cylinder. Which means, so if I look at what I did, I shortened the edges by 2, but then it would come out way farther. And the height, I changed it to 30. So that would mean that the 60, this is an over estimate. I also divided by 200 instead of 231, so 60 is an over estimate, which means that 178 is guaranteed to be wrong, 89 is guaranteed to be wrong, 59 is actually probably too close to the 60, so 44 is looking like a very phenomenal answer, and that's just with making estimates. Okay, so I do recommend making quick estimates. Notice that I did the work on paper for my estimates, but the truth is that you can make your estimates almost in your head. 20, 20, 30, 223 is 12, put zeros behind it, 12,000. Divide by 231, I'm not good with dividing by 231, I'm going to divide by 200. That makes the number bigger. Or I could actually reduce the numerator too by a little bit. So I could actually have divided like 10,000 divided 200, and I would have gotten something like 50. And that's giving me some pretty good answers. And it's giving 44 some really good vibes. So how do I do this problem though? This is a quarter cylinder. So the volume is equal to 1/4 of the volume of a cylinder, pi r squared h. And we remember that pi r squared h is in the back of the test. So we didn't have to memorize that, but we could have. So that is equal to 1/4 pi times 22 squared times h is 27. Now and this is in inches cubed. This is in inches cubed. So I'm going to get that number as a decimal, and then divide that by 27, move that over here, divide that by 231. So 1/4 times pi times 22 squared times 27. That then divided by 231, and I get 44.43. 44.43 and change. Okay? In fact, let me bring in the exact image, because I actually recommend to students to write the full decimal and then round after 10961. And the reason I do that is because if I only get to tell you one time, I have to tell you a way that corrects muscle memory errors. And so 44.43 rounds down to 44. That is definitely the correct answer. The one that was giving me really good vibes turned out to be the correct answer, which is great. So now you see the benefits of estimating. Number 18, line M, whose equation is y equals negative 2x plus 8, is dilated by a scale factor of 1/2 centered at the origin. Which equation represents the image of line M? Is it y equals negative x plus 4, or y equals 2x minus negative 2x minus plus 4, or y equals negative x plus 8, or y equals negative 2x plus 8? They love asking dilation problems when the point is either the origin or a point on the line. If you dilate a line through a point on the line is preserved. Meaning the original line and the new line are the same. If you dilate about a point on the origin, or literally any other point that's not on the line, dilations preserve angles. And they also preserve parallelism. So the original image and the new image are parallel. So line M, the line, I'm going to call it line M prime, has a slope of the same slope of line M, negative 2. So any of these choices that have a slope of negative 1, and literally anything other than negative 2 is guaranteed to be incorrect. And now we have a passing problem, which is phenomenal. Almost every single problem that we've done so far has been converted into a passing problem. But why do I eliminate this choice also, or strongly suspect that this one's wrong? Because we're dilating across a point that's not on the line. So the line itself is not going to be preserved. And this choice 4 is the same exact equation. If it was a point like, for example, the point 0,8. 0,8 is on the line. Dilate around across the point 0,8 and you get the same exact line. Or dilate across the point 4,0, you get the same exact line. Or dilate across the point, let's say 3,2. 3,2 is on the line. You get the same exact line, but not in this case because the origin is not on the line. So can I actually do this problem with 100% certainty? Yes, I can. I got a y-intercept of 8. I'm going to dilate it by a scale factor of 1/2 centered at the origin. I go halfway down. 8 divided by 2 is equal to 4. So the y-coordinate is going to be a 4 for the y-intercept. The original line had a slope of negative 2. Let's try drawing that line again. The slope of negative 2. So the new line is also going to have a slope of negative 2. And so its equation is going to be y is equal to negative 2x plus half of 8 is 4. So if you see where that slope of negative 1 came about, well, because they dilated they divided the slope by 2, but dilations don't change slopes because dilations preserve parallelism. Number 19, in right triangle RST below, altitude SV is drawn to hypotenuse RT. Which statement is always true? Is it that RT over ST, so always true, RT over ST equals ST over VT, or VR over VT equals VT over VS, or RV over SV equals SV over RT, or TR over VR equals VR over SR? I don't know if there's like a one best way of doing this problem. The thing you do need to know is that the left side triangle, a triangle VRS, is congruent to the right side triangle, triangle VT and VST. And that's also congruent to triangle SRT. And these letters are in the correct order, meaning that this is the order in which they correspond to each other. How can I actually know that, though? There is a way to know that. By the way, the reason that all three triangles are congruent, are similar rather. Oh, I said congruent. That's a false statement. I said I was going to preserve all mistakes, and I'm going to do that. Triangle RV, triangle VRS is similar to triangle VST, and that's also similar to triangle SRT. Those are the correct ordering of the vertices, but how do I know the correct ordering of the vertices to name these proportionality statements? So, first off, the way that I know that these triangles are congruent is actually by the angle-angle postulate. They all have right angles, so that's one pair of angles. And then the outside triangle, RST and RVS, both literally share the same exact angle R, which is congruent to itself by the reflexive property. And angle T is congruent to itself by the reflexive property. So the right side triangle and the outside triangle are similar. So by the transitive property, the left side triangle and the right side triangle are also similar. But how do I get the vertices in the correct order? So the way I do it, I go the outside triangle, left side triangle, and the right side triangle. So I put triangle here, triangle here, triangle here. The first vertex that I put for the name is the right angle. For the outside triangle, it's angle S. For the left side triangle, it's angle at V. And for the right side triangle, it's the angle at V. So what about the remaining vertices? Well, the outside triangle has angle R. That's this vertex. The left side triangle also has angle R, so that has to correspond to angle R in the outside triangle. The bottom triangle, the right side triangle, does not have an angle R. So I'm going to leave that blank for a second. Now, the outside triangle has an angle T. The left side triangle doesn't have an angle T, but the right side triangle has an angle T, so T corresponds to T. And now there's a blank for both of these triangles. The remaining vertex goes there, which is angle S, vertex S for both of them, it happens to be. So now I have the ordering of the vertices in the order that they correspond to each other. Now, how do I go about doing this problem? I start with crossing my fingers, and there's a proportion that I know to be true always, and I just always hope that it's there, and that's what I'm going to do. So I hope that VR over VS is equal to VS over VT. VR over VS equals VS over VT. That's a nice one to remember. And in fact, let's see. Is VR over VS equals VS over VT anywhere? No, it's not. So that one's lost. So how do I then go about verifying which one of these is correct? Now, my random number generator said that if I'm going to test out a choice, I'm always going to test out choice 1 first. So I'm going to test out choice 1 first. Let's hope that it's it. RT is a side of only the outside triangle. So now we're talking about, let's see, I'm going to name these 1, 2, and 3. Number these 1, 2, and 3. So this is 2, 3 on the outside triangle in that order. And ST is a side of both the outside triangle and the right side triangle. So I can only be working with the outside triangle and the right side triangle. And so ST for the right side triangle is vertex 1 and 3. So the only way for choice 1 to be true is again, these are the outside triangle. So it can only be true if these are the vertices, the corresponding vertices 2 and 3 on the left of the right side triangle, and also vertices 1 and 3 on the right side triangle. And in fact, on the right side triangle, vertex 2 and 3 is S and T, and vertex 1 and 3 is V and T. So this actually does end up being the correct answer, and we got lucky. And that kind of inspection is really the best way to go about this problem. I'm going to go for another cough drop. So, are there other ways of doing this problem? There are other ways of doing this problem. Like, this problem has appeared in a lot of the Regencies. So, if you want to memorize something, I'm not the biggest fan of doing a problem by just rote memorization. But if there's something that, if you want to memorize something, there is something that you could memorize. These proportions have to be true no matter what the lengths, and there are integer lengths that are satisfied by a special right not a special right triangle, a bunch of Pythagorean triples, 9, 12, and 15, and then that would make this 20, and that would make this 16, and that would make this whole thing 25. And then you can confirm which ones of these are correct by just plugging in the numbers. I'm not the biggest fan of doing problems that way, but that is one way you can go about it. Number 20. What is the measure in radians of a central angle that intercepts an arc length of 12 pi centimeters in a circle with diameter of 36 centimeters? Pi over 6, pi over 3, 2 pi over 3, or 3 pi over 2. So this, we go back to the browser and look for the formulas, because although radians are an extremely rare part of the old geometry regions, by the way, fun fact, radians not going to be on the new geometry regions. But if you're taking the geometry regions, it is worth listening to this problem, because this topic is a very big topic in Algebra 2. Let this be your first exposure. But luckily, it's no longer going to be on the geometry regions. Now, we might not know what a radian is, and I do hope that you do understand it. You know, it does say that 1 radian is equal to 180 over pi degrees, which is, yes, a weird number. It's like 57 degrees, but it's actually like a decimal number of degrees, 57 and some decimal number of degrees, which might feel weird, but we've actually measured angles in other things besides degrees. And that's what breaks students' intuition, so let's actually fix that. We've measured angles in a circle using percents, like in a pie chart. 1% is 3.6 degrees. That's a decimal number of degrees too. So we have measured angles in decimal numbers of degrees too. We've also measured angles in right angles. There's 4 right angles in a circle. There's 2 semicircles in a circle. There's 1 full circle in a full circle. So we can measure angles in fractions of a circle. But in this case, they tell us that 1 radian is equal to 180 over pi degrees. So what we can do, we can measure the angle in degrees and then convert that into radians. So here's our circle. Nice. Let's draw our diameter here. Now they did tell us that the diameter is 36, so if the diameter is 36, we got an 18 and an 18 here. Okay? And let's convert the arc into some number of degrees. So let's see. I see that 18, I see that 12 pi is like a little over 36, so the angle is going to be bigger than 90 degrees, so I'm going to draw it over here. Okay, I happen to know the angle measure, but because I've done this before, but I can calculate the number of degrees by using proportional reasoning. A fun fact: the radians is not going to be on the geometry regions, but it's still a heavy part of the Algebra 2 regions. So, and also proportional reasoning is going to be a heavy part of the regions going forward. So even if you don't know how radians work, proportional reasoning is a big part of it. You want to know how to do it using proportional reason. So let's see, the circumference is equal to 2 pi r, which is equal to 2 pi times 18, which is equal to 36 pi. Okay? And we want to know what the angle measure is for that 12 pi arc length. We got 12 pi, which is the part of the circle in the arc, divided by 36 pi. Well, that's equal to 1 over 3. But that's also equal to the angle measure, which I'm going to call it x. I'm going to call it actually x. And I'm going to put that x there. Okay? X divided by the angle measure of the full circle, which is 360 degrees. And we could solve for x via that good old cross multiplication. And we get 3x is equal to 360 times 1. Divide by 3. Divide by 3. And we get that x is equal to 120 degrees. 120 degrees. And so then how do we convert this degrees into a radian measure of the angle? Well, it does tell us that 1 degree is 100, what is pi over 180 radians. So 180, so pi over 180 radians over 1 degree is equal to some mystery number of radians, which I'm going to call it y radians. Y radians, just because I said x is the angle measure in degrees. I could have used x technically, but let's not. Y in radians divided by the angle measure in degrees, 120. Good old cross multiplication. Again, how many times have I cross multiplied on this test? Y times 1 is equal to 120 times pi over 180. And that's our answer. That's actually our answer. Y is equal to 120 pi over 180. The zeros canceled, so that's 12 pi over 18. And I could also use my calculator to simplify 12 pi over 18. Let me show you how to do that. So it doesn't simplify the pi, so you can't do it that way, but you could simplify the 12 over 18. 12 over 18, and you press the math button. The very first option when you press the math button, arrow frac, convert to fraction. Convert to frac, 2 over 3. So 12 pi over 18 is equal to 2 pi over 3, which is the angle measure of that angle. And with after number 20, we're going to have a little snack break to talk about snacks. If you don't need a snack break, feel free to just jump to the point of the video where I'm talking about number 21. But if you need a snack break, a bathroom break, please do leave the headphones in while you're doing that, so that you can hear about my information about snacks. Okay? So what do we do when we're going to the Regents and we want to bring a snack? If they let you in with a drink, I do recommend a Fairlife drink. This is not sponsored by Fairlife. The reason I recommend Fairlife as a drink, it's a very small volume, so it's not going to make you have to use the bathroom because you have to pee. It's also got it's very high in protein, 30 grams of protein, so it's going to reduce your hunger. It's got a small amount of carbs, 4 grams of carbs, so it doesn't boost your energy, but at least it takes away the hunger, and it does give you a little energy, and the 2.5 grams of fat is also very low. Very little energy, but the there are other ways to get that energy in. And one of the other things that I recommend is something like a pure protein bar. There are plenty of other snack bars around. Any snack bar that works for you is fine. The reason I recommend pure protein, this one has 5 grams of fat and 18 grams of carbs. We're not we're not talking about this to lose weight. We're talking about this to do well on the Regents, right? So the 18 grams of carbs is gonna give you some energy. Pure protein bars tend to be very chewy, so they make you eat them slowly. And they also got 20 grams of protein, so that will fill you up. Excuse me. You can bring water, and in fact I do recommend bringing water, but you don't want to drink so much water that you have to use the restroom. Coffee. I actually personally don't recommend bringing coffee. If you are a professional coffee drinker, meaning you've been drinking coffee every day, maybe coffee does make sense for you. But if you haven't been drinking coffee at all, like you're not a coffee drinker at all, I would recommend not doing that, because what coffee will end up doing is make you extremely hungry. That's one thing that coffee does. Even people who say coffee doesn't make them hungry are actually not correct, because the way they respond, it makes them feel full right up until the point when they get hungry, and then their body craves enormous amounts of carbs and unhealthy stuff. So the coffee does, but if you're not a professional coffee drinker, it'll make you hungry to a level of hunger that you've maybe never experienced in your life in just an hour. If you really are desperate, I would say bring decaf. Decaf does have a little bit of caffeine. Decaf does not mean caffeine free. It means the caffeine has been removed for the most part. Bring something high in caffeine. Bring something very low in caffeine, and that'll carry you through the test. but it might also make you hungry. Even decaf coffee will make you hungry, so I would be careful with that. My advice again, Fairlife and pure protein, and you'll be all set. All right, that is the end of our snack break. If you still need more time for your snack break, please pause before you going on to the video. But for the rest of us, we're going to jump on to number 21. A regular nonagon has a center point P. What degree rotation about point P will carry the nonagon to itself? 60, 90, 180, or 200 degrees? So we gotta think about what this is actually talking about. So we have a 9-sided polygon. So this is a little bit difficult to draw. But we'll do our best. Okay, we'll do our best. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we got 9 vertices, okay? And we're going to pretend that this is a regular nonagon, all right? So a rotation will have to carry a vertex to itself. Clearly a 360-degree rotation carries every vertex to itself. But some other rotations don't carry the vertex to itself, but will carry the nonagon, one nonagon vertex to another nonagon vertex, all the way around, so that the nonagon itself self-intersects. So thinking about it this way, there's some minimum number of degrees, which I'm going to call x, that rotates to this point. And so ideally that small angle would be here, but there aren't any angles that are that small. So we have to consider what happens if we keep rotating. Well, if we rotate x degrees, this point will also rotate x degrees to get to the next one. This one will rotate x degrees to get to the next one. X degrees, x degrees, x degrees, x degrees, x degrees, and x degrees. Notice that if you've rotated each one of them x degrees, it's rotated to itself. But I also notice that 9 of these x's is equal to the full circle, which measures 360 degrees. So 9x is equal to 360 degrees. So if I divide by 9, I get that x is equal to 36 divided by 9 is 4. So 360 divided by 9 is 40 degrees. And this is equal to the minimum rotation angle to map the regular nonagon to itself. So, well, 40 degrees, and let's see, is 40 degrees one of the choices? Well, unfortunately not. So, what do? If I rotate another 40 degrees, well, 40 plus 40 is equal to 80, and that eliminates choice 1, 60, because that's smaller than 80 and bigger than 40. Then I do another 40, that's equal to that adds up to 120, and that eliminates choice 2, 90 degrees. Add another 40, that's equal to 160 degrees. Add another 40, and that's equal to 200 degrees. And that confirms that choice 4 is the answer and that choice 3 is not. Could we have done process of elimination to eliminating choices? Yes, we could have eliminated 180, because since it's a nonagon, this bottom vertex rotated 180 degrees would have been rotated to some random floating point above the nonagon, not to another vertex. So we could have eliminated choice 3, which is worth noting because we want to be able to eliminate at least one choice for every single problem. And ideally, we can convert every problem to a passing problem. But number 22, if two sides of a triangle have lengths of 2 and 7, the length of the third side could be 9, 8, 5, or 4. I haven't seen this problem asked on a Regents in a while, but it comes from the triangle inequality. Okay, so if you have a triangle with a very small side and a very large side, so let's call that 7, let's call that 2, let's call this x. Well, if this is a Adrian's house, and this is Bill's house, and this is Cassidy's house. Which way is it shorter to walk from Adrian's house to Cassidy's house? I would say that walking in a straight line is the shortest path. Therefore, walking to Bill's house and then to Cassidy's house has to be at least as long, if not longer, than walking from Adrian's to Cassidy's. And in fact, since you're not going in a straight line path, that's actually how you define a straight line path. It's the shortest path. Then the 2 plus the x has to be greater than 7. So x has to be greater than 7 minus 2. Has to be greater than 5. But so x has to be greater than 5. And that eliminates choice 3 and choice 4. We now have a passing problem, which is great. But what is the maximum size? So what if Cassidy and Bill live as far as possible, so that BC is the longest one? Then x can't be, it has to be shorter than the walk from Cassidy's to Alan's house than to Bill's house. So x has to be less than 7 plus 2. So x has to be less than 9. So strictly less than 9, that eliminates choice 1, and then choice 2, x could be 8. That is a valid length. And in general, we see that all sides have to be length smaller than the sum of the lengths of the other two sides, and also larger than the difference in length of the other two sides. Number 23. The car tire shown in the photograph below has a diameter of 2 1/4 feet. Approximately how many rotations will the tire make in 1 mile? So you may wonder, valid question, how many feet are in a mile? And that is in the back of the test, conveniently. That is in the back of the test. It's right, let's see, feet to miles, feet to miles, feet to miles. Okay? So if you were to get a cap, we see that the height of the tire is 2 1/4 feet, so the circumference is equal to pi times 2 1/4 feet. So if we had to just do a quick estimate, just to eliminate some choices, see the circumference of a tire is bigger than 3 times 2, which is 6. So if we divide 5280 by 6, the number of rotations has to be less than 1,000. Less than 5280 over 6. 6 is, which is less than 6,000 over 6, so it's less than 1,000. So it has to be less than 1,000 rotations. But also, it's not like, this isn't like 3 times bigger than 6, so it's not like the 373 ends up being a little bit too small. My fake student me might not be sure about 373. Real teacher me is definitely sure that 373 is too small. But we have to treat this problem as if it were a part 2, because this is a part 2 question. We can't get this answer if we don't do the actual algebra. So this is equal to 2.25 pi. Then 1 mile is equal to 5,280 feet. If you want to know how many rotations it takes to get to 5,280 feet, you could just divide by 2.25 pi. I'm going to do proportional reasoning. 1 rotation divided by c is equal to r rotations divided by a full mile. So I'm going to replace this c with 2.25 pi. And now I'm going to cross multiply. And I get that 5,280 times 1 is equal to r times 2.25 pi. Divide by 2.25 pi. I'm going to need parentheses around that when I put it in the calculator, so I'm going to put parentheses, divide by 2.25 pi. So Get the calculator out. $5,280 times 1, if you don't believe that that's 5,280, there it is, divided by parentheses 2.25 pi, close parentheses, and we get this answer. We get 746.9671996. So 746.9671996, which is around 747 rotations. Which is the answer that I suspected was true, right? And with this number 24, we get to celebrate having a perfect part 1 and getting a 75 on this Regents. We need this problem to get that 75. Let's see. In quadrilateral town, TOWN, we got OW is congruent to TN and OT is congruent to WN, which additional information is sufficient to prove that quadrilateral town is a rhombus. Is it that ON is perpendicular to TW, or TO is perpendicular to OW, or OW is parallel to TN, or ON and TW bisect each other? So I'm going to try to make it so that, so this is TOWN. I'm going to make it so that this is automatically true without it being necessarily a rhombus. So we got TOWN. And if we have OW is congruent to TN and OT is congruent to WN, see, so this is automatically, this makes this a parallelogram. So it is definitely a parallelogram. So any other conditions that get put on this thing to make this thing a rhombus only has to satisfy it being a rhombus, not implying extreme things like already it's a parallelogram. That's a big piece of symmetry. So what if ON is perpendicular to TW? So if ON is perpendicular to TW, actually that is something that is true about rhombuses. If you draw rhombuses like diamonds instead of drawing them parallel, then yeah, that is definitely something that looks good. But so, and in fact, diagonals of a rhombus are perpendicular. So we're going to have to establish why that would actually imply it in a second. First, let's just, because right now fake student me is not sure if this is it, but I'm going to establish that the rest of these are wrong. How about TO perpendicular to OW? This is already a parallelogram. By making this perpendicular, now what I've done is convert this thing into a rectangle. This is choice B. This is choice 2. And this, a rectangle is not a rhombus, so that's wrong. If I have OW is parallel to TN, actually the fact that both pairs of opposite sides are congruent implied already that it's a parallelogram, which already implied that opposite sides are parallel. So this is already true. It's true about parallelograms. This still only implies that it's a parallelogram. And then ON and TW bisect each other. That's the diagonals bisecting each other. And that's actually true about diagonals of a parallelogram already. So this is already true. So this kit doesn't add any particular structure, any extra structure. So choice 2, 3, and 4 are eliminated. Choice 1 is the only remaining answer. So why does the diagonals of a rhombus being congruent, the diagonals of a parallelogram being perpendicular make the shape a rhombus? So by being perpendicular, we have that these two angles are both right angles. This side and this side are congruent. And this is congruent to itself by the reflexive property. So by side angle side, let's call it T, O, W, and N. And I'm going to call this that central vertex P. Triangle TPN, TPO is congruent to triangle WPO. And then by CPCTC, TO is congruent to OW. Making this a parallelogram with adjacent congruent sides, which is a rhombus. And we've gotten a perfect part 1 and a 76 on this Regents. That's pretty exciting. And we are going to move right on to part 2, where they tell us once again, these diagrams are almost definitely drawn to scale. And this is an extremely good piece of advice for the part 2s, 3s, and 4s, for the geometry Regents especially, because of this second detail. For all questions in this part, a correct numerical answer with no work shown will receive only 1 credit. In other words, not 0 credits. If you give the numerical answer and you don't show work, like if you know it's true but you don't know why it's true, but you give the number anyway, you get a point. I would also challenge you to say, if you actually know it's true but you don't know why it's true, then maybe chase after it, because 1, you might not actually be true, right? But 2, if you know that it's true, you probably could justify it, and you don't have to do it in all the standard ways. You could do it in any way that fits the problem. So I'll give you an example here. Number 25. In the diagram below, quadrilateral BCDE maps onto quadrilateral JKLM using a sequence of rigid motions, which does imply that they're congruent. And it does look like they're congruent. So this diagram so far seems to be drawn to scale. And determine and state the degree measure of angle D. So now let's look at the angle measures. That's an angle of 117. That's an angle of 70. So this is, and I always tell students this, not every diagram is drawn to scale. I really hate to say it, but the 70-degree angle looks a little bit too small to be a 70-degree angle. But the 117-degree angle looks a little bit too big to be a 117-degree angle. However, these are congruent to each other, and we're about to use scale. Anyway, watch this. So JKLM is congruent to BCDE, and JKLM. So I'm going to put the vertices of each of them on both diagrams. B, C, D, E, and J, K, L, M. Notice I went in order. B, C, D, E, J, K, L, M. B, C, D, E, J, K, L, M. All right? So these are congruent to each other because they can be mapped onto each other with rigid motions, which means that the measure of angle B and J are the same, 117 degrees. The measure of angle K and C are the same, 70 degrees. The measure of angle E and M are the same, 91 degrees. And the measure of angle D and L are the same, and they're a mystery degree, and it's okay that it's a mystery degree. We don't know the measure because they're asking for it. Watch us use scale anyway, even though this diagram is actually not drawn to scale, because the 70-degree angle looks more like a 45-degree angle. But here's the thing, the 70-degree angle is too small in look, but the 117-degree angle looks like almost a 135-degree angle. It's too big in look. And so notice that these two angles add up to 187, which means that the JM and KL are not parallel to each other, but they're close to parallel to each other. They kind of squeeze in at the end, which they do. And then the angle M measures 91 degrees, which is just slightly bigger than a right angle, and it is actually slightly bigger than a right angle, which means that even though angle J and K are not drawn to scale, so angle B and C are also not drawn to scale, angle M being drawn to scale, and the fact that K is too small while J is too big, that error cancels out. L is still drawn to scale. So if you guess an answer that looks like a correct number for angle L out of thin air, you might actually get lucky and get the answer right. So get your points. How do you get your points? By guessing based on scale. So I've already given you 24 methods of doing process of elimination for the choices 1 through 4. Now I'm giving you ways of possibly getting 1 point on part 2s, 3s, and 4s. So should you focus on only the part 1s? Absolutely not. If I guess any number that's slightly less than 90 degrees for L, I might get lucky and get the answer right. Somewhere between 80 and 90. Some angle between 80 and 90. If I just guess a number, I might get the right answer. However, I think I could just get this answer now. Because this is a quadrilateral. I know that the measure of angle L and the measure of angle D, let's look at this one on the right, the measure of angle D plus the measure of the other 3 angles, 70 plus 117 plus 91, has to be equal to 360 degrees. And if that sum is equal to 360, then I subtract 70, I subtract 117, subtract 117, and subtract 91, and for that I definitely used my calculator. The measure of angle D is slightly less than 90, like I predicted, 82 degrees. And that, if I had just guessed that number, I might have gotten lucky. Okay, number 26. This is the one problem that I'm not going to do on paper. I actually, for teachers watching this, I teach this on Desmos. I teach doing this on software, and it translates directly to doing this on paper. Because the thing is that the compass, that complicated tool, do I have a compass here? I do not. I used to have one. I wonder what I did with it. But the compass, all it is a tool for drawing circles. You put the needle down, you put the pencil down, you don't even have to move the object, you can move the paper to draw a perfect circle. So just remember that. The compass is just a circle drawing tool, and then the straight edge is a straight line drawing tool. So it says, given AB below, use a compass and straight edge to construct a line segment that is a quarter of AB. Leave all construction marks. So that's what I'm gonna do. Let's go to the browser. And I'm doing it this way. I committed to doing it this way because I wanted to show you that you could literally just do this on the fly if you're doing it on a screen. Okay, so I'm gonna label that as A, label that as B. So this is how I teach it. I teach it on paper. I really do. I teach it on Desmos, and it works. And students leave knowing how to construct so well, and then they learn that the compass is just a straight line drawing tool. So how am I gonna, I'm sorry, the compass is just a circle drawing tool. So I'm gonna draw circles, and use that to construct my line that's a quarter of the length of AB. So what am I gonna do first? The only things that I am allowed to construct, I'm allowed to construct circles with a center at a point that's already been constructed and a radius on a line segment that's already been constructed. Then I also allow myself to construct line segments through 2 points that have been constructed. Well, how do I construct points then? I construct points by intersecting lines and circles. I could intersect 2 lines, makes an X, that's a point constructed. I could intersect a line and a circle, that's a point constructed. I can intersect 2 circles, and wherever the circles intersect, that's a point constructed. So look at this. I'm going to construct circle from A to B, and I'm going to construct a circle from B to A. Notice that this constructed 2 new points where the circles intersect. Now, there's something special about these 2 line segments. I'm going to draw it from A to that point. This is a radius of circle A, and AB is also a radius of circle A, which means that AB and this line segment are the same length. And also A to this top point is also a radius of circle A, so the top and the bottom line segment are the same length. I've constructed 2 congruent line segments that are both congruent to AB. Now, I'm going to draw a line segment from B to this bottom point. Now, B to this bottom point is a radius of B, and AB is also a radius of circle B. So this line segment is also the same length as AB. And finally, circle B to this top point is also a radius of circle B. So all four sides of this quadrilateral that I just formed are the same length. So this is a rhombus. What's cool about a rhombus, the diagonals bisect each other. So that point here, which I'm going to label, I am going to label this point M. That's the midpoint of AB. I might as well label that point, I'm going to label it C actually. And that point I'm going to label it D. I don't have to label it, I just wanted to. So now I've constructed the midpoint of AB, which means I've constructed a line segment that's half the length of AB. AM is half the length of AB. So I'm going to draw that one in orange. So what about drawing a line segment that's a quarter the length of AB? Well, if I bisect AM, that line segment, the new line segments will have a length that's half of AM, which is already a half of AB. So half of AB is a quarter of AB. So I'm going to bisect AM using the same exact procedure I just used. I get a circle from A to M, a circle from M to A. Now this line segment, these circles intersect at this point. Perfectly valid question. It looks like the circles intersect at the line segment too. And there is a reason why they do intersect there. But suppose I didn't know that. I make sure to intersect at the circles. I draw that new rhombus, that little tiny rhombus. And that rhombus, for the same reason that all the sides are congruent in rhombus ADBC, this rhombus is quadrilateral is also a rhombus. So if I draw the vertical line segment there, the diagonals of that rhombus bisect each other. So I'm going to label that point N. And AN is a quarter of the length of AB. And that's my construction. So I draw these circles and I leave that. Okay? And so some teachers might complain and say, wait, what? But I didn't draw dashes or parts of arcs or parts of circles. I actually train my students to draw full circles. And I only give them permission to draw arcs maybe like the last day. And usually they don't anyway because they're so accustomed to drawing full circles. It's actually better to draw full circles. But that's the construction. That's pretty sweet. Let's take a screenshot of this and bring it over to the other board. So this is the drawing. So this would take the place of this is what the construction would look like if you draw full circles. If you just draw arcs, then a lot of the green just disappears. But then it confuses a lot of students. I don't like it that way. I don't teach it that way. Number 27. A dog sees a bird in a tree. The angle of elevation from the dog's eyes to the bird is 36 degrees, as modeled below. The dog is 18.5 feet away from the base of the tree. So this is 18 from here to here is 18.5 feet. And his eyes are 2.5 feet above the ground. Okay? Determine and state how high the bird is above the ground to the nearest foot. Now, this is another one, and I always tell students, like, if you find two diagrams that are not drawn to scale on this Regents, I will eat my hat. Except, I didn't say it for this one, so I don't have to eat my hat. This diagram, although it's technically not drawn to scale, we're still going to be able to use scale, again, but for a different reason than the previous one. I see that the 2.5 feet is much shorter than the 18.5 feet, which is great, but it's not so much shorter that proportionally speaking, it's not quite right. So because the 18.5 feet is a lot longer. So what that means is that this length, we can't judge it proportionally relative to the 2.5 feet. But we can judge it proportionally to the 18.5 feet, because this angle is 36 degrees. That makes this angle 54 degrees, and that is definitely drawn to scale. So the triangle itself is drawn to scale. This side, since the bottom is 18.5 feet, the top is also 18.5 feet. This side has to be shorter than 18.5 feet, and it has to be given to the nearest foot. So if I guess a length has to be less than 18.5 feet, and proportionally speaking, this length, if I guess it to the nearest foot or half a foot, because then this length is 2.5 feet, then I might actually get lucky and guess the correct height over here. Like if I were to guess, I would guess, like, well, if this is 18.5, this is close to 18.5, so it's not like half of 18.5, it's not like 9, maybe like, if I were to say like 14 or 13 or 14 plus 2.5, that makes it 15.5 to 16.5. If I just get 16. So get your points. Guess based on proportional reasoning. Proportions and scale. And my guess was 16. Let's see if my guess is good. Let's see if my guess is good. So how do I do this problem though? This is the leg. Let's get a different color here. This bottom side is the leg adjacent to the 36 degree angle. And this side is the leg opposite to the 36 degree angle. Opposite. OPP over adjacent. And then I remember SOHCAHTOA. TO over A. And I have the leg opposite and the leg adjacent, so I actually need tangent. Tangent of 36, I'm going to call this X, is equal to X over 18.5. Put the tan 36 over 1, so I can cross multiply. I got X times 1, which is equal to X, and that's equal to 18.5 tan 36. I don't know what that is equal to off the top of my head. But I get my calculator out, and it is already in degree mode, and I get 18.5 tan 36, and we don't want to round too early, and you're going to see why. 13.44. Okay. So what I teach students is I put the full decimal on the test. And you may say that's a lot of writing. So X is equal to 13.44103677. But the reason I do it is because it actually fixes a muscle memory issue that a lot of students have. And that's where they round to the wrong thing. So first I have them put the full answer, which didn't take that much time. And then I have them to circle the part that they have to round to, and then they get it. So the part that students get wrong though, X is not down to the bottom of the base of the tree. X is down to the dog's height. We have to add 2.5. X plus 2.5, so excuse me, plus 2.5, that's equal to 15.944103677. Then we go to the nearest foot, that's equal to 16. And they did say the nearest foot, they gave the units for us, so we don't have to give the units. And my guess was right, so I would have gotten a point. If I just wrote the number 16, I would have gotten a point. So this problem is about to give us an 80 on the Regents, and we see, like, we're only 4 problems into the part 2s, and only 4 problems into the 2-point part of the test, of the part 2, 3s, and 4s, and that gives us an 80. But we're also going to see how tough it is to get to a 90. But this will give us an 80, so it is worth our time to focus on the part 2s. Pure silver has a density of 10.5 grams per centimeter cubed. Samantha has a pure silver charm on her necklace in the shape of a sphere. The radius of the charm is 0.5 centimeters. Determine and state the mass of the charm to the nearest tenth of a gram. And we remember that if you just put in the number, then you get points. So here's a way to get your points. So I noticed that 10.5 gram sample could measure a cube of side length 1 centimeter, right? Now, this sphere has a radius of 0.5 centimeters. So, in fact, this sphere has a diameter of 1 centimeter, which means that this sphere would fit perfectly inside of this box, touching the edges. So if you imagine cutting off corners and bits of the box to get to the sphere, that gives us the an approximation for the mass of the sphere. And in fact, if I were to guess, I would guess a number. Remember, it's got to be to the nearest tenth of a gram, around the cube mass, 10.5, 1 by 1 by 1 cube mass, divided by 2. And if you did that, and you might guess a little above or a little below, you might get lucky. Unfortunately, this one does take a lot of luck, but we can get points that way. However, knowing the volume of a sphere is probably the relevant thing, because notice the point is that this volume is equal to 1 times 1 times 1, which is equal to 1. Right? The volume of the sphere is what really matters. Volume, and does the test have the volume of a sphere in the back of the test? It absolutely does. And so the volume of the sphere is 4/3 pi r cubed, and that's equal to 4/3 pi times 0.5 cubed. And let's get this as a decimal. So V approximately equals, let's get our calculator out, 4/3 times pi times 0.5 to the power of 3. And we get a decimal answer. Oh, it didn't come. Okay. Okay, so we get this answer. And what I told you, I recommend putting the full decimal. Oh, that was weird. It's not letting me grab the corner for some reason. Okay, so the V is approximately equal to 0.52359877756. So how do we get the mass? We know the density. So this is an important formula that the test doesn't give you, and I really do wish it did give it to you. But you have to come in knowing the following formula. Density is equal to mass over the volume. So that the 10.5 grams per centimeter cubed is equal to the mass. I'm going to call it, let m equal the mass, divided by the volume, 0.52359877756. Put this over 1, cross multiply. So I got the mass times 1 is equal to 10.5 times 0.52359877756. 0.7756. Now, why didn't I round early if they said to the nearest tenth? It's because they want us to round the mass to the nearest tenth. So I'm going to multiply this by 10.5. And that's equal to 5.49. So the m is equal to 5.497787144. This is the muscle memory part. I write the full decimal and then I circle the part that they want us to round to, nearest tenth. M is approximately 5.49, so 5.5. And they gave us the units gram, so we don't have to put the units. And look, 10.5 over 2 is 2.5, so if you guessed something close to 5.25, then you would have gotten, if you happened to guess 5.5, you might have gotten the right answer. So even though that seems like a very wild number to guess, it's very close to 5.25. So theoretically possible to get those points. How did that image get all the way down there? Who knows? Number 29. In triangle ABC below, DE is drawn such that AD is 4, DB is 8, AE is 3, and EC is 6. Explain why triangle ADE is similar to triangle ADC. Now, they did say the word explain, so we have to use words. This one, since it's not a numerical problem, we can't just do numbers and be done. However, if you do the numbers, if you do the work, even if you don't get the questions, the words right, if you do the numerical work, you can get the full points. Okay. So if I actually do, if I say this, angle A, so triangle AD and E and triangle ADE and triangle ABC, so angle A is congruent to angle A by the reflexive property. So similarity relations go from angle-angle or angle-side-angle. So in this case, I'm going to actually do AE over AC. So the short side, the left side of triangle AD and the left side of triangle ACB. So this is equal to 3 over 3 plus 6 is 9, which is equal to 1 over 3. And also the right sides of triangle AED and triangle ACB. So AD over AB is equal to 4 over 4 plus 8 is 12, which is also equal to 1 over 3. So this implies that AE over AC is equal to AD over AB. So why are these triangles similar? So triangle ADE is similar to triangle ABC because it satisfies the side angle side proportionality relation. The side angle side proportionality relation is that the two pairs of sides are proportional to each other and the included angles are congruent to each other. And that's a full 2-credit problem right there. Number 30, in circle E below, tangent PA and secant PBC are drawn. They sure are. Looks like it's drawn to scale. If PB is 9, okay, nothing to contradict that, and BC is 16, so BC looks almost double BP, so that looks good. Determine and state the length of PA. This diagram is drawn to scale. This diagram is drawn to scale. So if I guess something for AP that is appropriate based on the scale, AP is longer than PB. It's definitely shorter than PC. It looks very similar in size to CB. So if I guess something close to 16, I might get the answer right. So get your points. This diagram is drawn to scale. So guess something close to 15. It's close to 16, rather. And you might get your point. Now, how do I do this problem? There is a theorem that says that in a secant, the outer part of the secant, PB, times the whole secant length, PC, is equal to the square of the tangent, PA squared. So PB is 9 times PC is 9 plus 16. 9 plus 16 is equal to 25. 25, that's equal to PA squared. So 225 is equal to PA squared. Take the square root of both sides, take the square root of both sides, plus or minus, reject. So PA is equal to plus or minus 15. We reject negative 15 because PA is a length, which is greater than 0. So that PA is very close to 16 like we suspected, it's 15. And we're about to get a perfect part 2 with problem 31. Once we do problem 31, we will have a perfect part 2. In a right triangle, sine of 4x plus 3 degrees is equal to cosine of 2x minus 9 degrees. Determine and state the value of x. This is probably one of the worst written problems that I've seen in my life. And I hope the Regents creators hear me say that. Yes, in a right triangle, the opposite angles are similar. Are complementary. But what do these letters represent? How is a person supposed to know that these angles are the opposite angles in a triangle? Nothing in the problem says it. So Regents writers, you did unfortunately a very bad job in writing this problem. So I hope that you do correct that for future Regents. However, what can I do to do this problem? This is a problem that does lend itself to the calculator. So if you go to the calculator, okay, and you're in degree mode, and you type in this one, y equals sine of 4x plus 3, and on this one you do the cosine of 2x minus 9. And now if you just go to the table and scroll down, you might get lucky and get a value of x that has the two of them equal to each other. And in fact, when x equals 16, so if you just write 16 on the problem, you get credit. Another part of the writing of this problem that I don't like is that there are an infinite number of solutions. So if you zoom trig, you'll see that these two graphs are going to intersect multiple times. And any answer where they intersect is a valid answer. So I'm going to zoom in around here. Zoom in to. I'm going to zoom in around where I think they intersect. I go up and I go that way. Okay. And I press enter. And let's see where they intersect. Okay. And I see that they intersect like right around there. They also intersect right around there. So I'm actually going to use my calculator's intersection feature to get that intersection point. Calc in blue up here, so I press the blue second button and then calc. I'm going to get the intersect of these two curves, enter. I'm going to get the first curve, enter. The second curve, enter. And I'm going to actually guess, I get close to that intersection. And they tell me that x is actually equal to 16. So if I just wrote x equals 16 in the problem, I get the point. Now you might think, well, if I get it on the calculator and I just write x equals 16 and that's it, then I get a point, but I don't get 2 points. But actually, if you do graph it, so if you actually justify it by graphing it, and so then you type in, you write this, and then you graph that, and then you graph that, and then you put 16 here, and then the y-coordinate here, here, 0.9205. Then you say x equals 16, that might be worth 2 points. So it is possible to do it on the calculator and get your points. But is there a way to do this algebraically? Again, there is a problem with the way they wrote the problem. They didn't imply at all that 4x plus 3 and 2x minus 9 are the angles in the triangle. However, if you do assume that, okay, and you draw the right angle, and you do here 4x plus 3, and you do 2x minus 9, then I'm going to call this angle A, and angle B, and angle C. Then sine A is equal to the opposite leg over the hypotenuse, opposite leg to A. And this is this side CB, this is the opposite leg. And the hypotenuse is here. But also cosine of B is equal to the adjacent leg to B over the hypotenuse. Remember, so, ka, toa. But the bottom side is the side the leg that's adjacent to A. This is also the adjacent leg to B. So so sine of A is equal to CB over AB, but cosine of B is also equal to CB over AB. And so that actually is satisfied by the triangle. The equation is satisfied by this triangle, which means that if we just say that the sum of the two angles or the three angles is what we expect it to be, 180, so 4x plus 3 plus 2x minus 9 plus 90, that's equal to 180, then we actually have a way of getting a value of x, and it's a perfectly valid value of x. So minus 90, let's combine some like terms, 6x, let's combine the plus 3 and the minus 9, minus 6 equals 90, plus 6, we get that 6x is equal to 96, divide by 6, we get that x is equal to 16. So again, a poorly written problem with actually an infinite number of solutions, and there's nothing actually implying that those angles had to be the angles in a right triangle. Very badly written problem. And I would never say that if it wasn't actually true. A very badly written problem. So I'm wagging my finger to the Regents creators here. Okay, so let's go to number 32. And number 32 is a part 3 problem, where now these are 4-point problems, and we see that the diagrams are almost definitely drawn to scale. And again, the numerical answers will only receive 1 credit. So so let's read the problem. Modeled by right triangles below, a surveyor S is taking land measurements using a cabin C, a boulder B, and a tree T as fixed points for reference. The cabin, boulder, and tree are collinear. The surveyor is 917 meters from the cabin, 1,048 meters from the boulder, and 1,425 meters from the tree. Determine and state to the nearest degree the measure of angle BST. So if I make a guess assuming that this thing's drawn to scale, if I just make a guess as to what I think the measure of angle BST is, I might get lucky. Now let's actually determine if it is drawn to scale. So let's see, 917 relative to 1048. 1048 is about 150 more. It's like 20% bigger than the 917, which does look like that. And then the 1425 is what, another 300 feet more. So this is drawn to scale. So if I guess an angle that looks right, I might get lucky with a point. How do I do this problem though? This is another SOHCAHTOA problem. Okay? So I see that this is for triangle CBS. CBS. This is the hypotenuse, is 1048. And this is the adjacent side, 917. This is for this angle. This is the adjacent leg to S. So SOHCAHTOA. The adjacent leg over the hypotenuse. So cosine of S is equal to the adjacent leg over the hypotenuse, which is equal to CS over SB. So cosine of S is equal to 917 over 1048. Now you might say, wait, how can I possibly get S out of this? There's no algebra that I could do to cancel it. There is algebra that you could do to cancel. Every operation has an inverse operation, and the inverse of the cosine operation is the cos inverse operation. So that's actually how you could cancel the cos. So S is equal to cos inverse of 917 over 1048. And actually, I'm going to leave that angle measure there, although you can, if you choose, you can get it as a decimal. So let's quit this. Sine inverse 917 over 1048. Oops. And if I had to guess, I would guess around 30 degrees, maybe a little smaller. So if I had to just pick a number less than 30 degrees for this angle, 28 degrees. I don't actually know what it is, but that's my guess right now. Let's see how good I am at 28 degrees. Oops, I just said sine inverse. Sorry, cos inverse. I'm actually gonna, so I don't have to type it all, I'm gonna go right at the beginning and then do cos inverse. I said 28 degrees, let's see. It's 28.95. It's actually 29 degrees, so my guess was pretty good. But I'm not gonna actually use those numbers right now because I'm actually gonna use, the expression as is. I only got the number on the calculator so that you see that you can do it using the calculator. Now, if I do the same thing with triangle CST, now CST, well, in my triangle, it looks a little wide, but on their triangle, 917 and 1425, this looks like almost like a 45-90 triangle, 45-45-90 triangle. Let me stop this software real quick. This almost looks like a 45-45-90 triangle. Like my triangle that I drew looks a little wider. Theirs looks less. Like if I guess that it's like 46 degrees, that might be a good guess. And then 46 minus 28 was my guess. Would be a valid guess for this angle. Anyway, so let's actually do this. Recognize that this is the hypotenuse for triangle CST, and this is the adjacent leg to angle S. So again, cosine of B now, cosine of S. So I have to do a little correction. So cosine of angle CST is equal to adjacent 917 over hypotenuse 1425. And the correction that I have to make is here. It's not cosine of S. It's cosine of CSB. Cosine of CSB. So the measure of angle CSB is equal to that angle. So now on this triangle, the measure of angle CST is equal to cos inverse of 917 over 1425. Okay? And so that's this angle over here. So I got that green angle and I got this red angle without a dash. So how do I get the angle that we're looking for, which is the red angle with a dash? We could subtract these two angles. So the measure of angle BST is equal to the measure of angle CST minus the measure of angle CSB, which is equal to cos inverse of 917 over 1425 divided by cos inverse of 917 over 1048. Now I could type that into the calculator directly as is, or I could go into the calculator as I did with the first angle and get a decimal answer for that angle, cos inverse 917 over 1425. Enter. And so then the measure that I'm looking for is that big angle minus, and I said 46 degrees is my estimate, it turned out to be like 50. That angle minus the 28 degree angle. Bring that to the document over here. Let's try it one more time. Okay. Put the calculator away. And we get that the measure of angle BST is equal to 20.99101.546 degrees. And then we go back and see what they wanted to the nearest degree. The measure of angle BST equals 21 degrees. You might have gotten lucky with that guess. And I know that it's a lot harder to eke out by guessing points out of the part 2s and 3s. But I want to point out that the methods that we use to solve the part 2s and 3s are literally the same methods that we used for the part 1s. So if you're truly focusing on the part 1s, you need to do the part 2s, and you need to do the part 3s, and you need to do the part 4s. Number 33, a garden bed pictured below is a square prism with a rectangular prism taken out. The inside length of the square prism is 6 feet. The rectangular prism taken out has a width of 2 feet and a length of 4 feet. The diagram below shows the top view of the garden bed with its inside measurements. The garden bed is filled with topsoil to a uniform height of 1.25 feet. Determine and state the volume of the topsoil in cubic feet. Okay? So this thing comes out of the page like that. Like that. Okay? So how did I do this problem? I got the volume, I cut it into pieces. And I got the volume of the pieces. And in terms of getting your points, that's exactly what you do. Cut the diagram into pieces and calculate the volume. Now, there's another option. Instead of cutting into pieces and calculating the volume, you could have calculated the volume of the whole rectangular prism and then cut out that inner rectangular prism with a height of 1.25. So, but since I cut it into pieces already, I know that the volume then is equal to the length times width times height. Remember, the volume of a rectangular prism is equal to LWH. In general, the volume of any prism is the area of the base times the height. But so this area, the volume of this prism is LWH. So the first, I'm gonna call this V1, V2, and V3. So V is equal to V1 plus V2 plus V3, and that's equal to length times width, 2 times 4, times the height, 1.25, plus V2 is also 2 times 4 times 1.25, plus then V3, let's see, V3 plus, this one's 6, 2 plus 2 plus 2 is 6, 6 times, and then 4 plus 2, they already told us it's, 4 plus 2 is 6, so 6 times 2 times 1.25. And they don't require us to know arithmetic on this test, so you could actually just plug these numbers into the test, into the calculator. 20 plus 15 is 35. 10 plus 10 plus 15 is 35. So that's the volume of the topsoil. Okay? Now, the second part of this problem, each bag of topsoil sells for $3.68 and contains 2 cubic feet of topsoil. Determine and state the total number of bags of topsoil that must be purchased to fill the garden. The total cost of the bags of topsoil. Okay, so we know the volume is 35 cubic feet. Now, the number of bags of topsoil, so one bag, let T equal the number of bags of topsoil. The reason I like doing proportional reasoning is that when you do proportional reasoning, you don't have to memorize any equations. You could actually generate the equations via proportion. So one bag is equal to 2 cubic feet. So 2 cubic feet. Well, that's equal to a mystery number of T of bags over 35 cubic feet. Let's do our cross multiplication. Cross multiplication. 2T equals 1 times 35, divide by 2, divide by 2. You get T is equal to 17.5. But you can't buy a bag, half a bag, so T is equal to 18. Now the cost, I'm going to do proportional reasoning again. One bag, so the cost of one bag is $3.68. For one bag, and that's equal to, let C equal the cost of the bags. It's equal to C over 18. Do a cross multiplication. C times 1 is equal to 18 times 368. So C is equal to 18 times 368 is $66.24. And that is the answer to the question that they sought. And with number 34, we're about to get a perfect part 3. And I want to point out here, the test is 35 questions long. The test is 35 questions long. We are about to do number 34, and we haven't yet gotten a 90. So we actually need an extra point from problem 34 to get that 90. As crazy as that is, we actually have to go through all the way through to problem number 34 just to get the 90. And then we do problem 34 and problem 35 and we get our 100. So we're about to get a 90, let's do it. So given triangle ACD with ABC, AED, and BE parallel to CD. Prove that AB times AD, AB times AD is equal to AE times AC. That seems like a very far away thing to prove, but it's a 4-point proof. Believe it or not, there's tons of partial credit here. You don't get credit for writing the givens, but you do get credit for the very first true statement that is in the right direction towards the proof. And if you write anything at all that's correct in the proof, it's almost guaranteed to be in the right direction towards the proof. The remaining points are not like 2 statements, so 2 extra points, 3 statements, so 3 extra points. It starts actually measuring by how far away you are from the final answer. But I'm going to make a statement reason proof. Okay? And they did say the given information is triangle ACD with ABC and AED, and BE is parallel to CD, and that's given. So that's still 0 points, but anything that's in the right direction towards the thing I'm trying to prove will give me points. The fact that I see this multiplication makes me think that we're actually trying to do similar. We're trying to prove that 2 triangles are similar, and then use the corresponding parts of similar triangles are in proportion. So I'm going to focus on trying to prove the triangles are similar. And I noticed that because these 2 sides are parallel, I notice that these 2 angles have to be congruent. So 2 is that angle ABE is congruent to angle C. And this is because parallel lines cut by a transversal form congruent corresponding angles. If you said corresponding angles are congruent, that would have been enough. But that's a point. That's a point. Now I got a point and I got a 90 on this test. So statement 3, if I'm trying to prove that these triangles are similar rather, I know that the top angle is congruent to itself by the reflexive property. But I'm going to get a cough drop, despite the fact that I only have 1.5 problems left. I'm going to get a cough drop because I feel it. I feel it's not going to be fun. Okay, we're doing this. We're doing this. So number 3 is that top angle is congruent to itself. Angle A is congruent to angle A by the reflexive property. And that implies that these 2 triangles, triangle ABE and triangle ACD, have 2 pairs of congruent angles. That means that they're similar. So statement 4 is that triangle ABE is in fact similar to triangle ACD by the angle-angle postulate. And so where do I go from there? Well, if I know those 2 angles are congruent, I could say that their corresponding sides are in proportion. So 5 is that, so the left 2 sides, AB over AC is equal to the ratio of the right 2 sides, AE over AD. And the reason is that you could write CPSTP. This is like CPCTC, but for similar triangles. Corresponding parts of similar triangles are proportional. Okay? Now, statement 6, which is the very final statement for this proof. We're about to finish perfect part 3, which is exciting. If we cross multiply, we end up getting AB times AD, which is now the statement that they wanted us to prove, AE times AC. And the reason, a statement that a lot of teachers like for some reason, The means are AC and AE, and the extremes are AB and AD. And so we could say that the product of the means equals the product of the extremes. And that is a perfect part 3. And we are 6 points away from getting a perfect grade on this test. And of course, let's see. All diagrams are almost definitely, right? Definitely drawn to scale. Graphs naturally have to be drawn to scale by just facts, because that's part of the speaking of the same language. We are both, you and the test maker, you and me and the test makers are speaking the same language. One of the things that we have to assume is that if we have a graph paper, that it works the way that we know graph papers work. And the only way that it can work in a different way is if they actually tell us that. So this is our graph paper. And it says here, number 35, triangle PET has vertices with coordinates P, -6, 4, E, 6, 8, and T, -4, -2. Prove that triangle PET is a right triangle. Use of the set of axes on the next page is optional. I'm definitely going to use the axes. This is the set of axes on the next page. I just pasted it here. So -6, 4. E, 6, 8. And T, -4, -2. T, P, E. Now, when we graph these, we want to draw these with a straight edge. I'm going to draw this. I'm going to draw this. Valid question. Do graphs have to be drawn with a straight edge? Yes. Okay. So this is our triangle. And they're claiming that this is a right angle. And this is very much looking like this angle is going to be the right angle. So I'm going to use the fact that I could see it. See, if I didn't draw it, I would have had to guess at which angle might be the right angle. And in fact, how could I even have proved it if I didn't even know where to go from the numbers, right? So graphing it does help. So what do I know about right angles? Right angles are formed by perpendicular sides. So how can I prove that that PE and PT are perpendicular? Well, if I remember that perpendicular lines have slopes that are opposite reciprocals of each other. So I'm going to get the slope of PE and the slope of PT. The slope of PE is equal to, again, y2 minus y1 over x2 minus x1. So -6, 4. 4. I better not make that look like a -4. -6 and +4. And E has coordinates 6 and 8. So the slope of P is the delta y, change in y, over delta x, change in x, which is 8. The change in y is 8 minus 4 over the change in x, 6 minus -6, which is equal to 4 over... Let the calculator do 6 minus -6 if you don't know 6 minus -6, but 6 minus -6 is 12, which is equal to 1 over 3. Even the calculator could even simplify that ratio. Then the slope of PT is equal to, again, delta y over delta x. The coordinates of t are -4 and -2. And so this is equal to y2 minus y1. So -2 minus 4 over x2 minus x1, -4 minus -6. Again, let the calculator handle the arithmetic with positive and negative numbers. -4 minus 2 is -6. -4 minus -6 is -4 plus 6, which is 2. -6 over 2 is -3. 3. So the slope of PE is the negative 1 over the slope of PT, which is negative 1 over 3. So they are slopes of each they are opposite reciprocals of each other. So since the slope of PE is the opposite meaning one's positive, one's negative, okay, opposite reciprocal of the slope of PT, PE is perpendicular to PT, so what else? Perpendicular lines form right angles. So angle P is a right angle. Okay? So now we know this is a right triangle. We know that this is a right triangle. Now, state the coordinates of n, the image of P, after a 180-degree rotation centered at 1, 3. Luckily, they just want us to state it. They just want us to state it, which is a phenomenal thing. I just want to redraw this because it's going to matter. Come on, straighten out. It didn't straighten out. I actually needed to straighten out this time. Okay. The reason I needed it to straighten out is because I needed this to be more exact. The 0.13 is on that line. So if I go from P to N, I go down from P to N, I go down 1 and over 7. So if I go down 1 and over 7 again, I end up at the image of P. Oh, sorry. Okay, so I misspoke. This center point is not N. This point is N. This point is, I'm going to call it, let's see, P-E-N-T. P-E-N-T. I'm going to call it A. These are the coordinates of N. So N is the point 8, 2. Notice what I did again. I went from P, I went down 1 over 7 to get to A. Then I went down 1 over 7 again to get to A2. Since they only want us to state it, you could say 8, 2, and you got your point, okay? Notice in this one, speaking about partial credit again, you can get that point independent of whether you figured out the answer to the first part of the problem. Okay? So we are about to get a perfect grade. So we're going to finish this problem, drop the mic, and say bye and congratulate ourselves for getting a perfect grade. So the next part of the problem is to prove that PENT is a rectangle. Okay? So I'm going to draw that line segment, and I'm going to draw that line segment. Okay? So how do we prove that this is a rectangle? There's a lot of ways of proving that this is a rectangle. You could prove that it's a parallelogram with a right angle. You could prove that it's a quadrilateral with congruent diagonals, which bisect each other. You could prove that the length of all the four sides, the opposite sides, are congruent, and that the slopes are opposite reciprocal of each other. What I'm going to do is I'm going to prove that all four sides have slopes that are opposite reciprocals of each other. Okay? So, which means that it'll be a parallelogram with a right angle. Okay? So the slope of En is equal to delta y over delta x again, which is equal to 2 minus 8 over 8 minus 6, which is equal to negative 6 over 2, which is equal to negative 3. So the slope of En is equal to the slope of PT. So PT is parallel to En. I'm going to do the same thing with Tn and Pe. The slope of Tn is equal to delta y over delta x, changing y over changing x, which is 2 minus negative 2. Let's try that again. 2 minus negative 2 over 8 minus negative 4, which is equal to 2 plus 2 over 8 plus 4, which is equal to 4 over 12, which is equal to 1 over 3. So the slope of Tn is equal to the slope of Pe. So Tn is parallel to Pe. We're about to drop the mic. One more sentence, and we've completed a perfect grade on this Regents. And I want to thank you for being a part of this video. Thank you for having watched this video as far as you did. If you feel like I've earned your subscribe, thank you. If you feel like if I've helped you during these watch hours, please do comment and let me know that I've helped, because your appreciation is part of my motivation. And if you have any questions at all, please do ask them. I do have a tutoring company, JuanTutors.com. If you have any interest in hiring me as a tutor, please do check out JuanTutors.com. All right. At this point, though, we're about to finish this sentence and drop the mic. So let's see. We've already proved that this quadrilateral has opposite sides which are parallel. So PENT is a parallelogram because opposite sides. Wait, it's a parallelogram. That's not the symbol for a parallelogram. It's a parallelogram because opposite sides are parallel. PNT also has a right angle. At P. And then here's the final sentence. We're about to drop the mic. A parallelogram with a right angle is a rectangle. So PNT is a rectangle. And now, that's it. So we pick up the mic, we've dropped the mic, we've gotten a perfect grade on this test. Congratulations. I'll see you in the next one.